There is a close analogy between learning English language and learning C language. The classical method of learning English is to first learn the alphabets used in language, then learn to combine these alphabets to form words, which in turn are combined to form sentences, and sentences are combined to form paragraphs. That means there is an analogy, that means there is a procedure to learn any language. For example, English language, if we are trying to learn, first we have to learn alphabets, then we have to learn how to combine those alphabets and form words, and then we should learn how to form sentences, and then paragraphs. So C language is like that only. Learning C is similar and easier. Instead of straight away learning how to write programs, we must know alphabets. That means we first uh, go from smaller steps, or we must took smaller steps, and then we are going to learn complex things in that language. So learning C is similar to this. So instead of straight away learning how to write programs, we must know alphabets. That means we must know the basic things, basic and smaller things. Steps in learning English language: first we have to learn alphabets, then we have to learn words, then we have to learn sentences, and then we have to learn paragraphs. So these are steps involved in learning of English language. Now steps in learning C. First is alphabets, digits, special symbols, then constants, variables, keywords. Now instructions, and then program. So steps in learning English language are similar to those of steps in learning C. So they have a similarity in this. So alphabets are similar. It contains C language also contains digits, special symbols, etc. Now instead of words, they have constants, variable, keywords. That means int, char, etc. These are constants, variables, and keywords. So we have a set of keywords or table of keywords also. Now sentences. Instead of sentences, we have instructions here. C language has instructions. Now paragraphs. That means in language, in English language, we are writing paragraphs. That means if we want to write an essay on a particular topic, so we will write a paragraph, and in this C language, we will write a program. This C character set. So this is character set of C program. A character denotes any alphabet, digit, or special symbol used to represent information. So a character is a representation of alphabets, digits, or any special symbols used to represent information. First is alphabets. So capital A, B up to Y, Z. So these are set of capital letters of English language. Now small a, b up to y, z. So these are small letters in English language. Digits from 0 to 9. Now special symbols are these. So these are special symbols. So it includes symbols like at the rate, then hash, then percentage, and brackets, plus, minus, is equal to, not equal to, curly brackets, square brackets, semicolon, etc. So question mark. So these are special symbols used in language. A character denotes any alphabet, digits, or symbol, special symbols used to represent that information. That means it is denoting information or representing information just like English language, but it has a certain limited set of that those symbols or characters of that information. So it is basically denoting numbers, special symbols, and alphabets. Constants, variables, and keywords. The alphabet, numbers, and special symbols, when properly combined, form constants, variables, and keywords. So, when these alphabets, numbers, and special symbols are combined, then for those combination, keywords are used. A constant is an entity that does not change, whereas a variable is an entity that may change. That means constant does not change and variable is changing. That means if we define in a mathematical sense that f of x, if we consider an equation f of x is equal to y, so x is changing. So there are variables, several variables and constants, so we will discuss about them. In a program we typically do lots of calculations. The results of these calculations are stored in computer memory like human memory. The computer memory also consists of millions of cells. These the calculated values are stored in those memory cells. So this is about computer memory. So it has millions of cells. So in any program we typically do a lot of calculations and the results must be stored somewhere. So results are stored in computer memory. That means we have dedicated memory, that means 1 GB, 2 GB, etc. So these are memories units, MB, KB, GB, etc. So like human memory, the computer memory also consists of millions of cells. That means 1 bit binary cell is a basic unit in computer memory, that is 1 bit binary cell. So it consists of millions of such cells. The calculated values are stored in those memory cells. Since the values stored in each location may change, the names given to these locations are called variable names. So as a value which is stored in each location can change, that means uh, that value is stored somewhere in memory, so it should be located where it is stored. So we have to give name for that location. So we have to give name for that location, and since value of stored in each location may change, the names given to these locations are called variable names. So we give names to these locations, and these names are called variable names. So these are two boxes. In this example, 3 is stored in memory location and a name x is given to it. So 3 is stored in a memory location and a name x is given to it. That means in first box x is 3 and in second box x is 5. Then we are assigning a new value 5 to same memory location x. So we are assigning a same value 5 to memory location x. So we are assigning values. This would override the earlier value 3 since a memory location can hold only one value at a time. So at first x was 5 and now we are overwriting that x as 3. Now since a memory location can hold only one value at a time, we have to overwrite it. Since the location whose name is x can hold different values at different times, x is known as a variable. So the place where x was situated, it can hold different values at different times at different locations, and x is known as a variable. Now x is known as a variable as against these 3 or 5 do not change, hence these are known as constants. So 3 and 5 are not changing. So digits from 0 to 9 they are not changing. 3 is 3 and 5 is 5, but x is now changing. So x is a variable and 3 and 5 are called constants. Types of C constant. So in this topic we are discussing about types of C constants. So there are various C constants. C constants can be divided into major categories. First, primary and secondary. So there are two main categories, which are primary category and secondary category. So in primary category there are integer, real numbers and characters. So this comes under primary category. Now in secondary category there are array, pointer, structure, union and enum. So this is a table for C constants category, that is primary, secondary, and these are two blocks in which it is divided. For constructing these different types of constants, certain rules have been laid down. These rules are as under. So we cannot construct this constant in any manner. So there are certain rules which has been laid down. Laid down means they have been applied. So there are certain rules which have been applied. These rules are as under, so as follows. Rules for constructing these integer constants. So first were integer constants, and rules for constructing, there are certain rules for constructing those integer constant. First, an integer constant must have at least one digit. That means first is it must have at least one digit. Then B, it must not have a decimal point. So integer cannot have int, integer cannot have a decimal point. So this is second rule. Now third rule, it can be either positive or negative. So we can apply a negative sign also, but it can be either positive or negative. So this is third rule. If no sign precedes an integer constant, it is assumed to be positive. So if there is no negative sign in front of or before an integer constant, so it is considered to be positive. So plus. Now no commas or blanks are allowed within an integer constant. So we cannot within an integer constant we cannot apply comma, that we do in our day to day work. For example, if we want to write like $1,000, so after one we give a comma and then we write three zeros. So we cannot do this in this language. No commas or blanks are allowed within an integer constant. So this is rule D. uh, Rule E. The allowable range for integer constant is -32768 to +32767. So rule number F is the allowable range. That means the range in which we can apply integer constant. That means we can do calculation is 32,768 to 32,767. Truly speaking, the range of an integer constant depends upon the compiler. So it depends upon range of this integer constant is depending upon the compiler. For a 16-bit compiler like Turbo C or Turbo C++, the range is -32768 to +32767. So it depends upon the compiler. So this compiler is 16-bit compiler like Turbo C and Turbo C++. These are 16-bit compilers. So for those compilers, range is this. For a 32-bit compiler, range would be even greater question. Like what exactly do you mean by 16-bit or 32-bit compiler? What range of an integer constant has to do with the type of compiler, and such questions are discussed in detail in this chapter. So basically for 16-bit compiler range was different. Now for 32-bit compiler the range is different. That is for 16-bit compiler we are we have limited range. Then for 32-bit compiler we can do 32-bit operations at one time. So it has a different range. till that time it would be assumed that we are working with a 16-bit compiler. Example, 426 plus 782 minus 8000 minus 7605. So till that we are assuming that we are using a 16-bit compiler, but we have to remember that rules for 32-bit compiler are different than that of 16-bit compiler. Now, rules for constructing real constants. Following rules must be observed while constructing real constants expressed in fractional form. So, while constructing real constants in the real constant are in fractional form, so while considering those fractions, we have a certain rules and they must be observed. First, rule a real constant must have at least one digit. That means it should be at least single digit number. B, it must have a decimal point. That means it should have a decimal point. So that is rule B. Now rule C, it could be either positive or negative. So it can be either positive or it can be either negative. So that is rule C. Now rule D, default sign is positive. So if no sign is given, then default sign is positive. Rule E, no commas or blanks are allowed within a real constant. That means no comma or no blank are allowed within a real constant. So as in general in real life we apply commas or blanks. So in this language we cannot use commas or blanks. Now examples. First is 325.34, that is positive number. Now here sign is not given, but it is still a positive number. 426.0. Now minus 32.76. So here sign is given, that is negative sign. So it is a negative number. So this was third number. Now fourth number is minus 48.5792. So this is a negative number because the sign is given here. The exponential form of representation of real constant is usually used if value of constant is either too small or too large. So if value of that constant is either too small or too large, then exponential form of representation of real constant is given. That means it can be represented in exponential form. Following rules must be observed while constructing real constants expressed in exponential form. So we can express numbers and real constant in exponential form, but there are few rules for expressing them in exponential form. Rule A, the mantissa part and the exponential part should be separated by letter E. So the characteristic and mantissa part is separated by letter small e. So as we see in log function, that is this part is separated by e for logarithmic calculations. Rule B, the mantissa part may have a positive or negative sign. That means mantissa can be positive or it can be negative. So that is rule B. Now rule C, default sign of mantissa part is positive. That means mantissa, if minus, that is negative sign, is not mentioned, then it is considered to be positive. Now the rule D, the exponent must have at least one digit which must be positive or negative integer. Default sign is positive. That means exponent, that is number before e, so it can be positive or negative, but default sign is positive if not given negative. Rule E, range of real constants expressed in exponential form is minus 3.4e38 to plus 3.4e38. So this is range. of real constants. Examples of real constants are plus 3.2 e minus 5, 4.1 e 8, minus zero point 0.2 e plus 3, minus 3.2 e minus 5. So these are range of exponential form of real constants. Rules for constructing character constants. Rule A. So there are some rules for constructing character constants. First is rule A. A character constant is a single alphabet, a single digit. A character constant is a single alphabet, a single digit enclosed within a single inverted commas. Both inverted commas should point to left. For example, A is a valid character constant whereas A is not. That means both inverted comma should point to left. So that is uh, first rule, rule A of character constants. Rule B, the maximum length of a character constant can be one character. Example, A I phi is equal to. So the maximum length can be one character only. Types of C variables. So there are various types of C variables. As we saw earlier, an entity that may vary during program execution is called a variable. A variable names are names given to locations in memory. So an entity that vary during program is called a variable. So variable names are given to given when variable names are given, they are stored in locations in memory. These locations can contain integer, real or character constants. So locations in which variables are stored, they can contain integer, real number or character constants. In any language, the types of variable that it can support depend on types of constant that it can handle. So type of variables that a language can support, they depend on types of constant that it can handle. This is because a particular type of variable can hold only the same type of constant. That means a particular type of variable can hold the same type of constant also. So type of variable it can support depend on type of constant that it can handle. For example, an integer variable can hold only same type of constant. A real variable can hold only real constant, and a character variable can hold only character constant. So there are various sections for integer, then for real variable and character variable. So there are various partitions for these types of separate variable variables. Now rule for constructing variable names. A variable name is any combination of 1 to 31 alphabets, digits or underscores. Some compilers allow variable names whose length could be up to 247 characters. So variable names is any combination of 1 to 31 alphabets, digits or underscores, and some compilers, that means there are some specific compilers who allow variable names whose length could be up to 247 characters. Still, it would be safer to stick to rule of 31 characters. Do not create unnecessarily long variable names as it adds to your typing effort. So you can use 31 characters, but do not create unnecessarily long variable names because it can add a very typing effort. So in program we have to type these names again and again. So unnecessarily these variable names can add to typing effect. Then rule B, first character in the variable name must be an alphabet or underscore. So this is rule number B, that is first character in variable name must be an alphabet or underscore. Rule C, no commas or blanks are allowed within a variable name. So no commas or blanks are allowed in a variable name. Now rule D, no special symbols other than underscore as in gross underscore cell can be used in variable name. So rule D is no special symbols other than underscores. So underscore can be used, but no special symbols other than an underscore as in gross underscore cell can be used in variable name. Example si underscore int. Now m underscore hra, pop underscore e underscore 89. So these are special symbols other than an underscore. These rules remain same for all type of primary and secondary variables. Naturally, the question follows, how is C able to differentiate between these variables? This is rather simple matter. So these rules remain same for all type of primary and secondary variables. So these rules are same for all primary and secondary variables. C compiler is able to distinguish between the variable names by making it compulsory for you to declare the type of any variable name that you wish to use in program. This type of declaration is done at beginning of the program. Following are the examples of declaration of statements. So basically how this C compiler is able to distinguish between variable names is by programmer will have to declare them or specify them before the typing program or before execution of program. So example of these are int si comma m underscore hra. So this is an integer. Float basal, so this is a basal is a float. Now char is character, that is code. So we have to define each variable uh, before execution of program or before writing of that program. So these are few examples of integer variables. Since maximum allowable length of a variable name is 31 characters, an enormous number of variable names can be constructed using above mentioned rules. Thus, if we want to calculate simple interest, it is always advisable to construct meaningful variable names like PRIN, ROI, NOI to represent principal, then rate of interest and number of years. So, if we want to calculate some meaningful uh, product like rate of interest or simple interest, so variable name should be meaningful also. So here that PRIN is representing the principal. Now ROI is representing the rate of interest. Now NOI is representing number of years. So this is basically the variable names. C keywords. Keywords are words whose meaning has already been explained to C compiler or in a broad sense to computer. The keywords cannot be used as variable names because if we do so, we are trying to assign a new meaning to keyword, which is not allowed by computer. Keywords are also called reserved words. So basically keywords have meaning and they cannot be used as a variable name. because we are assigning a new, if we are using a keyword as a variable name, then we are assigning in a sense a different meaning to a keyword. So keywords are special words and also called as reserved words. So there are many keywords in C. These are keywords in C. First is auto, second is break, third is case, fourth is care. So this is useful character. Now constant, const, const, continue, then default, do, double, else, enum, extern, float, for, go to, if, int, long, register, return, short, signed, size of, static, struct, switch, type, diff, union, unsigned, void, volatile, and while. So these are few keywords which are used in C language. Note that compilers like Microsoft, Borland, etc. provide their own keywords apart from ones mentioned. These include extended keywords like near, for, ASM, etc. So there are some special compilers like Microsoft, Borland, etc. They provide their own keywords apart from these C keywords. So these keywords are near, far, ASM, etc. The first C program. Now we will study first C program. Armed with knowledge of types of variables, constants and keywords, the next logical step is to combine them to form instructions. Before we begin with our first C program, do remember following rules which are applicable to all C programs. So now we are armed with the knowledge of all type of variable, constants and keywords. So now the next logical step is to combine them to form instructions. Now we are combining them to forming instructions. Before we begin with our first C program, do remember following rules which are applicable to all C programs. So before beginning with our first C programs, we have to remember following rules which are applicable to all C programs. So these are basic rules. Rule A: each instruction in C program is written as a separate statement. Therefore, a complete C program would comprise a series of statements. So each instruction in C program is written as a separate statement. That means each instruction is separate. So the complete C program would comprise of series of statements. That means it will contains a series of statements. That means it will contains a lot of statements. So lot of statements are written in series. So this is rule A, or we can say that it is a common thing that each statement is separate and they are combined together, all statements. So C program is basically combination of these statements. Rule B: the statement in program must appear in same order in which we wish them to be executed, unless of course the logic of problem demands a desirable jump or transfer of control to statement which is out of sequence. That means statement will appear in same order. That means it will perform task in same order as we have mentioned, unless we are jumping somewhere or we are transferring to some part of code. So that we will discuss in jump instructions, etc. So it says that statements in program appear in the same order in which we wish them to be executed, unless of course the logic of problem. So they appear in same order in which we wish them to executed. So this is rule B. Now rule C: blank spaces may be inserted between two words to improve the readability of statements. So blank spaces may be inserted between two words to improve the readability of statement. However, no blank spaces are allowed within variable, constant or keyword. So blank spaces may be inserted between two words. That means if we are typing int 3, so between that int and 3 we are giving space, but we have to also note that however no blank spaces are allowed within a variable, constant or keyword. That means we should know that within variable we should not do this. That means if we are writing a variable, then there are no spaces allowed in that within a variable name. If we are defining a variable as apple, so we cannot give space between that a p p double p l e, so we cannot give space between that. So we have to know that also. So this was rule C. Rule D: all sentences are entered in small case letters. So all sentences should be entered in smaller case letters. So this is rule D. Now rule E: C has no specific rules for position at which a statement is to be written. That is why it is often called a free form language. So it has no rules or position at which statement should be written. So we can write anywhere, uh, any statement anywhere. So that is what why it is called free form language. So in Arduino, when we are programming Arduino, we have to write or define variables, or uh, what can we say, that we are using some numbers or we are using some characters that we have to define at beginning of program. So while coding with dealing with Arduino, so C is not like that. C has not specific rules for the position at which statement is to be written. That is why it is often called a free form language. Rule F: every C statement must end with a semicolon, thus acts as a statement terminator. So every C statement must end with a semicolon. So semicolon is compulsory for every statement. So this is rule F. Let us now write down our first C program. It would simply calculate simple interest for a set of values representing principal, number of years and rate of interest. So first we will write down a C program which would calculate simple interest for a set of values. So this is basically a program of simple interest, that is P into R, N into R. Main. So this should be written in every program. Main, then int pn, so integer p and n, that means p and n are two integers. Now float r and si, so r and si are two floats, that means they have decimal digit in their number. Now p is equal to 1000, now n is equal to 3, and r is equal to 8.5. So simple interest, so this is formula for simple interest. SI is equal to P star N star R divided by 100. So this is formula for simple interest. Now printf percent f comma SI. So simple interest is printed now here. Comment about the program should be enclosed within these brackets. For example, the first two statements in our program are comments. So these were comments. So we can write comments like this. Though comments are not necessary, it is good practice to begin a program with comment indicating purpose of program, its author, and the date on which the program was written. So comments are not necessary, but it is good practice to begin a program with a comment, so we can understand what this program is about. So reader can understand for what this particular line in program is written for. So comment are important for that. Any number of comments can be written at any place in program. For example, a comment can be written before statement, after statement, or within statement as shown below. So the any number of comments can be written. So it can be 1 2 3 any number, so they can be also written in any place. So this is an important point, that it can be written anywhere. So anywhere means it can be written at before program, then between program and after program. So this is example of that. So comment in star formula, then slash complete, si is equal to p slash p star n star r divided by 100. So formula is a comment. So from this line we understand that this is a formula for simple interest, and this is a line for formula. So comments are useful in this way. Sometimes it is not so obvious as to what a particular statement in a program accomplishes. At such times, it is worthwhile mentioning the purpose of statement or a set of statements using a comment. So we use comments to better explain what program is, or what a particular statement in a program is. Often programmers seems to ignore writing of comments, but when a team is building big software, well commented code is almost essential for other team members to understand it. So whenever a team is building a big software or a big code, then comments are useful for other team members to understand what this code is about. Although a lot of comments are probably not necessary in this program, it is usually the case that programmers tend to use too few comments rather than too many. So programmers tend to use too few comments. That means sometimes they use uh, few comments rather than too many. Now comments cannot be nested, for example, so they cannot be nested. So this is one comment, cal of si, then author Sam, date 0101 2002. So this is invariant. So comment can be split over more than one line, but they cannot be nested. So comment can be split over more than one line, just as in this is a jazzy comment. Such a comment is often called a multi-line comment. So this is a jazzy comment. So this such a comment often called a multi-line comment. The comment can be split over more than one line. Main is a collective name given to set of statements. This name has to be main. So this is basically a function. So it is a collective name given to set of statements. This has to be main. All statements that belong to main are enclosed within pair of braces as shown below. So all statements that belong to main are enclosed within pair of braces. Now main, statement 1, statement 2 and statement 3. So this is basically a pair of braces. So these statements are in main. Technically speaking, main is a function. Every function has a pair of parentheses associated with it. So every function has a pair of parentheses. That means these are brackets which are associated with it. So technically speaking, main is a function. Any variable used in the program must be declared before using it. For example, integer p comma n. So any variable used in program. So integer is used in program. That is p comma n. So these are integers. So they must be declared before using it. That means float. So r and si are float. P and n are integers. So they must be used. They must be declared before using it. Any C statement always ends with a semicolon. For example, so semicolon is important in any C statement. So any C statement ends with a semicolon. For example, float r comma si. Then r is equal to 8.5. So semicolon is given after float r comma si. Then r is equal to 8.5, semicolon is given. In this statement, si is equal to p star n star r divided by 100 semicolon. So star and slash are the arithmetic operations Arithmetic operators in arithmetic operators available in C are plus, minus, star, and slash. So these are arithmetic operators. C is very rich in operators. There are about 45 operators available in C. So there are 45 operators which are available in C. Once the value of SI is calculated, it needs to be displayed on screen. Unlike other languages, C does not contain any instructions to display output on screen. All output to screen is achieved using ready-made library functions. So we have to display this information, that is we have to print this information on screen. So unlike other languages, it does not have any function, it does not have any instruction to display output on screen. All output to screen is achieved using ready-made library function, so that is printf. Printf, we have to use this function to display on screen. The general form of printf function is printf. So this function is basically used for displaying data on screen. So we use this printf function for this purpose. So general form is printf in uh, inverted commas. Inverted commas are two. So in two inverted commas, format string, that is that it can be %d, it can be for integer, signed integer, it is %d, then %c, etc. So that is format string. Now list of variables. Second is list of variables, that means the variables which we have to print, that is p, n, r, etc. Now format string can contain %f for printing real values, then %d for printing integer values, %c for containing for printing character values. So format string contains these things: %f, %d, and %c, and all. There are other variables also, so they are used also. In addition to format specifiers like %f, %d, and %c, the format string may also contain any other characters. These characters are printed as they are when written when printf is executed. So in addition to format specifiers like %d, %c, and %f, so other there are other the other variables which are used. Following are some examples of usage of printf function. So printf %f si. So then so printf is %f is for printing real values. Then so these are examples of basically printf functions. So printf %d, %d, %f, %f in p, n, r, si. So p, n, r, and si are these variables. Now printf simple interest rs is equal to %f comma si. So uh, so simple interest is in program, so it is %f, so which is real value. Now printf print %d is n rate. So these are basically examples of printf functions. The output of this last statement would look like this: print is equal to 1000, rate is equal to 8.5. So this is output of the last statement. So what is /n doing in this statement? It is called new line, and it takes the cursor to next line. Therefore you get the output split over two lines. So /n is used for the shifting the cursor to next line. That means we are printing on next line with /n. /n is one of the several escape sequences available in C. Right now all that we can say is /n comes in handy when we want to format the output properly on separate lines. So /n is useful when we want to format output. That means we want to go to next line, then /n is handy, or it is useful. Printf cannot only print values of variables, it can also print the result of an expression. An expression is nothing but a valid combination of constants, variable and operators. So printf cannot only print values of variables. So we know that that printf is printing value of variable or value of integers, etc. So it is not like only it will print value of variables, it can also print the result of an expression. An expression is nothing but a valid combination of statements, variables and operators. So when we print an expression, so it is a valid combination of constants, variables and operators. So we can say like that first some words, so it will be combination of words also, then integers also, and constants also, so and variables also. So it is not like that printf function is only printing variables, it is also printing other things and combination of other things also. Thus 3 comma 3 plus 2 c and a plus b star c minus d are all valid expressions. The result of these expressions, so these are basically expressions. So 3, then 3 plus 2 comma c, so this is a plus b into c minus d, is it's a expression. All these valid expressions, the result of these expressions can be printed as shown below. Printf in inverted commas percent d, percent d, percent d. So percent d is for integers. So 3 is an integer, 3 plus 2 is an integer, then c is an integer, a plus b star c minus d is an integer. Note that 3 and c are also represent valid expressions. Now compilation and execution. Compilation and execution. Once you have written the program, you need to type it and instruct the machine to execute it. So once you have written the program, so we write program and you need to type it and instruct the machine to execute it. So we are instructing machine also to execute it. For that, to type your C program, you need another software called editor. So we write C program and then we turn it into hex file. So for turning this program into hex file, we need a compiler. So once you have written the program, you need to type it and instruct the machine to execute it. So we are instructing machine to execute it by compilation. Now to type C program, you need another software called editor. So for typing C program, we need another software called editor. So it is used for typing program. Once program has been typed, it need to be converted to machine language, zeros and ones, before machine can execute it. Once program has been typed, so that means program is now typed and it needs to be converted into machine language, that is zeros and ones, that is hex code, before machine can execute it. So before machine can execute it, we have to convert this code into zeros and ones. So for that matter, compiler is used. To carry out this conversion, we need another program called compiler. Compiler vendors provide an integrated development environment IDE, which consists of an editor as well as compiler. So compiler vendor, that means there is an IDE called integrated development environment. For example, the for microcontroller 8051, there is an IDE called Kill, MuVision Kill. So we need an IDE. So IDE has all of these things called as compiler, then it has compiler, then for typing that program, editor it has, then for run that program it has another software. So IDE, that is integrated development environment, consists of all these things. There are several such IDEs available in market, targeted towards different operating systems. So there are various integrated development environments available in market. So they are different according to different system. different systems, that means different operating systems like Windows, then Linux, then there is uh, etc. Macintosh. So these are operating systems. So there are several IDEs available in market targeted towards different operating system. For example, Turbo C, Turbo C++, and Microsoft C are some of the popular compilers that work under MS-DOS. So there are few compilers which work under MS-DOS such as Turbo C, then Turbo C++, and Microsoft C are some popular compilers. So these are popular. Turbo C and Turbo C++ are more popular, and Microsoft C is also there. So these are some compilers that work under MS-DOS. Now assuming that you are using a Turbo C or Turbo C++ compiler, here are steps that you need to follow to compile and execute your first program. Assuming that you are using Turbo C or Turbo C++, that means here we are discussing about Turbo C and Turbo C++. Here are steps that you need to follow to compile and execute your first program. So there are steps which you need to follow for execution of first program. First, step A, start the compiler at C prompt. C, that is command prompt. The compiler tc.exe is usually present in c.tc c/tc/bin directory. So tc.exe is usually present in c/tc/bin directory. Now step B, select new from the file menu. Now we have to select new file from file menu. C is type the program, so we are typing program. Now save the program using F2 under proper name, say program1.c. So we are saving program using F2 under proper name like program1.c. Step E, use Ctrl plus F9 to compile and execute the program. That means after checking errors we are compiling it. So we are using Ctrl plus F9 to compile and execute the program. Step F, use Alt plus F5 to view output. So for viewing output we are using Alt plus F5. Note that on compiling the program, its machine language equivalent is stored as exe file, that is program1.exe on the disk. So its machine language equivalent, that means the hex file, it is stored as exe file, that is program1.exe on disk. This file is called an executable file. If we copy this file to another machine, we can execute it there without being required to recompile it. So this file is called an executable file. If we copy this file another machine, we can execute it. So this is hex file. Now it is created after compiling, so we can execute it without being required to recompile it. So we can execute this file without in different machine. So if we copy paste this file in different machine or a different computer, we can still execute this file. A word of caution, if you run this program in Turbo C++ compiler, you may get an error. The printf function should have prototype. To get rid of this error, perform the following steps and then recompile the program. So Turbo C++ is a special case of special compiler in which this error of printf function may occur. We have to eliminate this error, and for that elimination we have to perform the following steps. First, step A, select options menu and then select compiler C++ options. So in options menu, select compiler and then C++ options. In the dialog box that pops up, select CPP always in the use C++ option. So in after selecting that compiler/C++ option, there will it will open a dialog box that pops up and we have to select CPP always in the use of C++ compiler options. Now again, so step B is again select options menu and then select environment slash editor. So in environment section we have to select editor. Make sure the default extension is C rather than CPP. So default extension should be C rather than .cpp. Now receiving input. In program discussed above, we assumed values of P, N and R to be 1000, 3, 8.5. If we want to calculate simple interest for some other set of values, then we are required to make relevant changes in program and again compile it and execute it. So if we want to calculate simple interest, so we have to make relevant changes like that. Thus the program is not general enough to calculate simple interest for any set of values without being required to make change in the program. So this is that program of what we were discussing about. So first is main function. So this can be any, but main is the function, general function. So main, then semicolon, sorry, parenthesis, then in bracket int pn. So we are here defining integers, that is p and n are integers, p comma n are integers. Now float r comma si. So r and si are float. Now printf, here comes the printf function, enter value of p and r. So after printing that enter values of p and r, we have to scan those values. So all are integers except r, because r is float. So we are typing scanf %d %d %f. So and p and n and r. So r is a float, so that is why we wrote %f. Now si is equal to p star n star r divided by 100. Printf %f comma si, that is simple interest, that is si, and then program is complete. So in this program that we just have discussed, we have values of p, n and r to be 1000, 3 and 8.5. If we want to calculate simple interest forms for some other set of values, so we have to we are customizing it here. So then we are required to make relevant change in program, that is we have to take values, that is scanf. Thus program is not general enough. Thus this program is not general enough to calculate simple interest for any set of values without being required to make change in the program. So we have to take input from the user, that is we have to receiving input, we have to receive input. So this is this program cannot receive input. We have to make changes in program as a programmer, but user cannot change its value or use this program, and user cannot enter values as input. So thus the program is not general enough to calculate simple interest for any set of values without being required to make change in the program. Thus reception of input or receiving of input part comes in between. So it is important to receive input for a program, so it is done by scanf function. So receiving part is very important in a program or for a synthesis or for analysis purpose. Moreover, if you distribute the exe file of this program to somebody, he would not even be able to make changes in program. Hence it is a good practice to create a program that is general enough to work for any set of values. That means if we are distributing a file of this program, so he will not be able to recompile it. So it is a good practice, that is it is a good sign to create a program that is general enough to work with any set of values. So that program should work with any set of values. To make the program general, the program itself should ask the user to supply the values of p, n, and r through the keyboard during execution This can be done using a function called scanf. So the program itself should ask user for supplying of values of p, n and r. That means that those values which are required. So through keyboard means user will type on keyboard. During execution, this can be done using a function called scanf. So this is done using a function called scanf. So scanf function is used for taking those values. This function is called a counterpart of printf. That means it is opposite of printf. So that is counterpart. That means it is opposite of printf. So function printf outputs the values to screen, whereas scanf receives them from keyboard. So printf function prints value to screen, and scanf is used for receiving those values from the keyboard. And this is illustrated in the program shown below. So there is a program which is illustrating this. Main intpn. So main is function. Now in this function intpn, that means p and n are integers. Now float r comma si. So r and si are float. That means they have a decimal point. Now printf enter values of p, n and r. So we are here entering values of p, n and r. Scanf %d %d %f and p comma and n comma and r. So here %d and %d are for integer values and %f is for float values. Now si is equal to p star n star r divided by 100. That means this is formula for simple interest, p n r by 100. Now printf %f comma si. That means the answer will be in float, that is %f comma si. The first printf outputs the message enter values of p comma n comma r on screen. Here we have not used any expression in printf, which means that using expression in printf is optional. That means first printf outputs message enter values of p comma n comma r. That means first it is asking for entering values on screen. Here we are not used any expression in printf, which means that using expression is optional. So printf is for only explaining that you have to enter those values of p, n and r. And here we have not used any expression in printf, which means that using expression in printf is optional. That means here we are not using any equation or any mathematical calculation in printf. So that means using such mathematical expression in printf is optional. Note that the ampersand, that is and, so and is called ampersand here, before the variables in scanf function is must, and is an address of operator. So we have to compulsory write and before variables in scanf function. It is because it is an address of operator. It gives the location number used by variable in memory. So it gives us location number used by variable in memory. When we say and a, we are telling scanf at which memory location should it store the value supplied by user from keyboard. So when we are typing and a, then we are telling scanf at which memory location should it store the value uh, supplied by user from keyboard. So and is basically for storing value in particular memory location from keyboard. Note that a blank tab or a new line must separate the values supplied to scanf. So a blank tab or a new line must separate values supplied to scanf. Note that a blank is creating using a spacebar tab using tab key, and new line is using enter key. This is shown below. So a blank or a tab or a new line must separate various values supplied to scanf. So we have to separate values which are supplied to scanf. Examples. So these are three values. The three values separated by blank are 1000, 5, 15.5. So these are three values which are separated by blank. Now the three values separated by tab: 1000, 5, 15.5. Now third example, the three values separated by new line. So 1000, 5 and 15.5. So first was separated by blank, second was separated by tab, and third was separated by new line. That is, we have to enter. Main int num. So integer is a number, so int num. So main was a function, so main is written. Now printf, enter a number. So we are writing about entering a number. So printf, so we will print on screen that enter a number. Now scanf, %d and num. So and num is for is address of that number. So and num. So %d is for integer values, %d and num. Printf, now I am letting you on a secret. So now we are printing, now I am letting you on a secret. So we are printing, now now I am letting you on a secret. Printf, you have just entered the number %d num. So now we are printing, we are just entered the number %d num. So this was a basic program using scanf and printf function and address. So and num was used in this program. So output of this program will be, you have just entered the number and so whatever number we have entered, so you have just entered the number, it will be displayed. So it will be displayed, so output will be, you have just entered the number. So this was about using of printf and scanf functions. C instructions. So in this topic we are discussing about instructions in C. Now that we have written a few programs, let us look at instructions that we used in these programs. There are basically three types of instruction in C. So there are some instructions in C, so we will discuss about that. A is type declaration instruction, so this is first type. Then arithmetic instruction, so this is second type. Then control instruction, so this is third type. So there are three types of instructions in C. The purpose of each of instruction is given below. A, type declaration instruction, it is to declare the type of variables used in C program. So type declaration is to declare type of variables which are used in a C program. Second is arithmetic instruction, to perform arithmetic operations between constants and variable. So arithmetic instruction is for performing arithmetic operations between constants and variables. So we know there are a lot of arithmetic uh, arithmetic things or arithmetic calculations are involved in a program. So for performing those operations, we need arithmetic instructions also. Now see control instruction to control the sequence of execution of various statements in a C program. So it is for controlling sequence of execution of various programs. That means it is about the sequence of execution of these programs, of these statements. So for that control instructions are used. Type declaration instruction. This instruction is used to declare the type of variables being used in program. So this is used for declaring the type of variable used in program. Any variable used in program must be declared using it in any statement. So any variable used in program must be declared before using it. Now the type declaration statement is written at beginning of main function. So before main function, that type declaration is done. So examples are as follows: int bas. So bas is integer. Now float rs, gross sal. So gross salary. So these are floats, that means numbers having decimal point. So this is example of float. Now char, that is name and code. So these are characters. So these are three examples of int, then float, and then char. There are several subtle variations of type declaration instruction. These are discussed below. So there are several variations in type declaration instruction, so which are discussed below. First, A, while declaring the type of variable, we can also initialize it as shown below. So before declaring type of variable, we can also initialize it. So int I is equal to 10, then j is equal to 25. So before while declaring the type of variable, so we have declared that I is an integer, but we are also declaring its value as 10. I is equal to 10, that is also we are declaring. Now j is equal to 25, so value of j is also declared. Now float a is equal to 1.5, then b is equal to 1.99 plus 2.4 star 1.44. So these are floats. Now B, the order in which we define variables is sometimes important, sometimes not. So order in which we define the variables, that means the sequence in which we define variable is sometime important or sometime not. The order in which we define the variables is sometime important, sometime not. So the order in which we are defining variables is considered sometimes, and sometimes it is not. For example, so we will study example of this. int I is equal to 10, comma j is equal to 25. It's same as int j is equal to 25, comma I is equal to 10. So here in first statement I is written first, but in second statement j is written first. So it is same, second statement is same as first statement. However, float a is equal to 1.5, comma b is equal to a plus 3.1 is alright, but float b is equal to a plus 3.1, comma a is equal to 1.5 is not. This is because here we are trying to use a even before defining it. So here in this statement 1, here we are defining a is equal to 1.5, and then we are giving a comma, and then we are writing b is equal to a plus 3.1. But in second statement or second sentence, we are writing first b is equal to a plus 3.1, and then we are writing a is equal to 1.5. That means first we don't know a, but we are writing b is equal to a plus 3.1. So how the compiler or the program will know that value of a? So it is not possible, because first we will have to define a. So the first sentence, float a is equal to 1.5 comma b is equal to a plus 3.1, is true, and second is not true. See, the following statements would work: int a b c d semicolon, then a is equal to b is equal to c is equal to 10. So this was first statement. However, the following statement would not work: int a is equal to b is equal to c is equal to d is equal to 10. Now once again we are trying to use b to assign to a before defining it. Once again we are trying to use b to assign for a before defining it. So in first statement we have defined int abcd, and then after defining abcd we are writing a is equal to b is equal to c is equal to d is equal to 10. So first we have defined abcd, but in second statement we have not defined anything. So once again we are trying to use b to assign to a. So we used b for assigning to a as assigning to a. We used b as assigning to a, but we have not defined b, but still we are assigning it to a. So it is not possible, but for in first statement it is possible. Arithmetic instructions. A C arithmetic instruction consists of a variable name on left hand side of is equal to, and variable name and constant on the right hand side of is equal to. So in a C arithmetic instruction, a variable name with variable name and constants are on the right hand side, and when only variables are on the left hand side of is equal to. The variables and constants appearing on right hand side of is equal to are connected by arithmetic operators. So variable and constants which are on right hand side of is equal to are connected by arithmetic operators like plus, minus, star and divide. So star is for multiplication. So variable and constants appearing on right hand side of is equal to. So right hand part of is equal to sign consists of arithmetic operators which are plus, minus, multiplication and divide, etc. Example: int add, float, quote, data, alpha, beta, gamma. So add is an integer, so it is declared. Then quote, data, alpha, beta, gamma are float. Now add is equal to 3200. So integer is on right hand side. and name of that integer add is on left hand side. Now quote is equal to 0.0056. So float is on right hand side and name of that float is quote, that is on left hand side. Now data is equal to alpha multiplied by beta divided by gamma plus 3.2 multiplied by 2 divided by 5. So data, that is name of variable, that is data, so it is on left hand side, and alpha into beta divided by gamma plus 3.2 into 2 divided by 5 is on right hand side. So here multiplication, divide, subtraction and plus, that is addition, are arithmetic operators, and is equal to is assignment operator. So multiply, divide, minus and plus are arithmetic operators, and is equal to is assignment operator. Now 2, 5, 32, 00, that is 3200 are integer constants. 3.2 and 0.0056 are real constants. Add is an integer variable, and quote, data, alpha, beta, gamma are real variables. The variable and constants together are called operands that are operated by the arithmetic operators, and result is assigned using assignment operators to the variables on left hand side. So on left hand side there are only variables, and on the right hand side there are variables uh, with assignment operators, that is plus, minus, etc. So the variable and constants together are called operands. So when they are used combined, variables and constant are used combined, then they are called operands that are operated upon by arithmetic operators. So that are operated upon by arithmetic operators, that means these operands are operated op, the arithmetic operators are being operated on these operands, and the result is assigned using assignment operator. So result is assigned, that means uh, it is given using assignment operator. That means assignment operator is equal to variable on left hand side. A C arithmetic statement could be of three types. These types are as follows. Type A, integer mode arithmetic statement. This is an arithmetic statement in which all operands are either integer variables or integer constants. So arithmetic statements have several types. So first type is integer mode arithmetic statement. This is an arithmetic statement in which all operands are either integer variable or constant. First example, int I, king, Isaac, note it. So this is an arithmetic statement in which all operands are either integer variable or integer constants. So I is equal to I plus 1, king, Isaac into 23 plus note it minus 7689. So either they are either integer variable or integer constants. Second type is type B, real mode arithmetic statement. This is an arithmetic statement in which all, so second type is real mode arithmetic statement. Operands are either real constants or real variables. Example, float, qb, antic, si, prin, annoy, roi. qb is equal to antic plus 23.123 divided by 4.5 into 0. So this is basically In this type of statement, operands are either real constants or real variables. So float is used in this type. Now mixed mode arithmetic statement. This is an arithmetic statement in which some of operands are integers and some operands are real. So it has a mixed type of statement. So examples of this statement. Example: float si print annoy roi avg int abc num si print annoy roi divided by 100.0 avg is equal to a plus b plus c plus num divided by 4. It is very important to understand how the execution of an arithmetic statement takes place. So how execution of this arithmetic statement takes place. So here we are understanding how execution of an arithmetic statement is taking place. Firstly, right hand side is evaluated using constants and numerical values stored in the variable names. So first right hand side is evaluated using constants and values stored in variable. So this value is then assigned to variable on left hand side. So first execution is performed on right hand side and then it is assigned on left hand side. For example, in this statement, average is equal to a plus b plus c plus num divided by 4. So this value on right hand side is assigned as average, which is on left hand side. So uh, the places in so the values in right hand side are evaluated first. Though arithmetic instructions look simple to use, one often commits mistake in writing them. So arithmetic instructions look simple to use, but one often commits mistake in writing them. Let us take closer look at these statements. Note these following points carefully. So these arithmetic instructions are simple, but user can commit mistakes in while using them. So these are a few points. Point A: C allows only one variable on left hand side of is equal to, that is on left hand side there should be only one variable, that is z is equal to k into 1 is legal, but k into 1 is equal to z is illegal. That means only on left hand side only one variable is allowed, but on the right hand side more than one variable is allowed. So this is rule or point number A. B: in addition to division operator, C also provides a modular division operator. This operator returns the remainder on dividing one integer with another. So there is another modular division operator, that means which returns the remainder on dividing one integer with another. Thus the expression 10 by 2 yields 5. So we can write like 10 by 2 which results in 5, whereas 10% 2 yields to 0. Note that the modulus note that percentage, that is modulus operator, cannot be applied on float. So it can be only applied on integer, it cannot be applied on float. Also note that using percentage sign of the remainder is always same as the sign of numerator. So percentage sign of remainder is always same as the sign of numerator. Thus minus 5% 2 yields minus 1, whereas 5% minus 2 yields 1. C. So point C: an arithmetic instruction is often used for storing character constant in character variable. So arithmetic instruction is used for storing character constant in character variable. For example, char a b d. So a is equal to f, b is equal to g, and d is equal to plus. When we do this, ASCII values of the characters are stored in the variables. ASCII values are used to represent any characters in memory. The ASCII values of f and G are 70 and 71. So ASCII values of the characters are stored in the variable ASCII values, which are used to represent any characters in memory. So there are ASCII values assigned also. So this was point C. Now point D. Arithmetic operators can be performed. Arithmetic operations can be performed on ints, floats, and chars. Thus, the statement char x y int z x is equal to a, y is equal to b, z is equal to x plus y. So arithmetic operations can be performed on ints, floats, and chars. Since the addition is performed on ASCII code values of characters and not on characters themselves, the ASCII values of A and B are 97 and 98 and hence can definitely be added. So ASCII values of A and B are 97 and 98. So addition is performed on ASCII code values of characters and not on characters themselves. Now rule E, that is the point E. No operators are assumed to be present, it must be written explicitly. In the following example, the multiplication operator after B must be explicitly written. So A is equal to C into D into BXY. That is, this is a usual arithmetic statement and it is converted to C statement like B is equal to C into D into B into X into Y. This is C statement. So this first was usual arithmetic statement and C statement is written like this. Now point F. Unlike other high level languages, there is no operator for performing exponential operation. Thus following statements are invalid. So there is no operator involved for performing exponential operation. Thus these statements are invalid, which are as follows. So A is equal to 3 multiplied by 2. B is equal to 3 raised to 2. So these statements are invalid. If we want to do the exponential, we get it done this way. So we have to use a separate math function for this. If we want to do the exponential, we get it done by this way. So for performing exponential operation, we need to perform in different way. We have to add a library. That is, this code will explain the how to include this library. Now first line is hash include math.hex. So here we are including library, that is math.hex. Then there comes a main function, that is, this function is compulsory. Now int a, that means a is an integer. Now a is equal to power pow in bracket 3 comma 2. So this is a library function. Pow is a library function of math.hex library. Now printf %d because a is an integer, so we have to write %d for it. Comma a means that a in the previous line, that is %d comma a. Now bracket is completed. So here we have included math.hex function. Here pow function is a standard library function. So pow is a standard library function. It is being used to raise 3 to power of 2. So it is used for raising 3 to power of 2. Hash include math.hex is a preprocessor directive. It is being used here to ensure that the pow function works correctly. So include math.hex is a preprocessor directive means we are telling compiler that, or we are predefining that. That's why it is called preprocessor. That means before processing. Directive means giving direction. The statement giving direction. So directive is statement giving direction. Then preprocessor means before processing. So preprocessor directive. So include math.hex is a preprocessor directive. That means it is a library function. It is being used here to ensure that POW function works correctly. So it is being used here to ensure that POW function, that is POW function, is works correctly. So it is it should be written before that POW function. Now integer and float conversions. Integer and float conversions. In order to effectively develop a C program, it will be necessary to understand rules that are used for the implicit conversion of floating point and integer values in C. So in order to effectively develop integer and float conversions, so we should know these rules that are used for implicit conversions of floating points and integer values in C. These are mentioned below. Note them carefully. That means these rules are as follows for integer and float conversions. Point A, an arithmetic operation between an integer and integer always yield an integer result. So operation between one integer and another integer will yield an integer result. B, an operation between a real and real always yields a real result. That means if both are uh, real numbers, then it will always yield a real result. So operation between integer will yield in integer result, and operation between real will yield real result. C, an operation between an integer and real will always yield a real result. That means operation between integer and real will yield a real result. In this operation, the integer first promoted. So operation between an integer and real will always yield a real result. An operation between an integer and real always yields a real result. In this operation, the integer is first promoted to a real and then the operation is performed, hence the result is real. So uh, in so integer so the operation between integer and real always will yield a real result. So I think a few practical examples shown in the following figure would put issue beyond doubt. So these are some practical examples uh, between operation between real and integer. Now operation result. So operation 5 by 2, that is result is 2. Now 5.0 divided by 2, so 5.0 is float now, and divided by 2 it is result is 2.5. Now 5 divided by 2.0, it is 2.5. Now 5.0 divided by 2.0 is 2.5. Now operation 2 divided by 5, that is 0. Now 2.0 divided by 5, it is 4. Now 2 divided by 5.0, it is 0.4, and 2.0 divided by 5.0, it is 0.4. So these are operations and relations between integer and real. Type conversion in assignments. It may so happen that the type of expression and type of variable on left hand side of the assignment operator may not be same. So it can happen that type of the expression on the left hand side and assignment operator may not be same. In such a case, the value of the expression is promoted or demoted depending on type of variable on left hand side of is equal to. For example, consider following assignment statements. int I float b, I is equal to 3.5, b is equal to 30. Here the first assignment statement, though the expression value is a float 3.5, it cannot be stored in I because it is an int. So int is an I, so it cannot be stored in. So 3.5 is a float, but I is declared as an int, so it cannot be stored in I since it is an int. Similarly, in such a case, float is demoted to an int and then its value is stored. Hence what gets stored in I is 3. Exactly opposite happens in next statement. So here the float gets demoted and only 3 will be stored. Here 30 is promoted to 30.0000 and then stored in B, since B being a float variable cannot hold anything except a float value. So that means 30 is promoted to 30.000. So it was written wrong that it was an integer, it was a float, but it was actually integer. So it is promoted to 30.000 and then stored in B, since B being a float variable, it cannot hold anything except a float value. For example, consider the following program fragment. So if we look at following program fragment, float a comma b comma c int s is equal to a star b star c divided by 100 plus 32. So this is here the assignment statement. Some operators are ints. Here in the assignment statement, some operators are ints whereas others are floats. As we know, during evaluation of expression, ints would be promoted to floats and the result of expression would be float. But when this float value is assigned to s, then again demoted to int and then stored in s. So basically float should be written as floats and int should be written as ints. So here in the assignment statement, some operands are ints whereas some are floats. So in this statement, some operands are ints and some are floats. As we know, during evaluation of expression, the ints would be promoted to float. So int will be promoted to float and result of expression would be a float and result will be float. But when this float value is assigned to s, again it is demoted to int and stored in s. Observe the results of the arithmetic statement shown in figure. It has been assumed that k is an integer variable and a is a real variable. So on left hand side there is arithmetic instruction and on right hand side there is result. So k is equal to 2 by 9, so the result is 0. Now k is equal to 2.0 divided by 9, so result is 0. Now k is equal to 2 divided by 9.0, so result is 0. Now k is equal to 2.0 divided by 9.0, so the result is 0. Now k is equal to 9 by 2, result is 4, because now 9 by 2, the answer of 9 by 2 is 4.5, but integer is declared, so result is 4. Only 4 will be considered. Now k is equal to 9.0 divided by 2, so the result is 4. Now k is equal to 9.0 divided by 2.0, so the result is 4. K is equal to 9.0 divided by 2.0, so the result is 4. So a is a real variable. Now a is equal to 2 divided by 9, that is 0.0. Now a is equal to 2.0 divided by 9, so the result is 0.2222. Now a is equal to 2 divided by 9.0, so result is 0.2222. Now a is equal to 2.0 divided by 9.0, so the result is 0.2222. Now a is equal to 9 divided by 2, so the result is 4.0. So a is equal to 9.0 divided by 2, so result is 4.5. A is equal to 9 divided by 2.0, result is 4.5. A is equal to 9.0 divided by 2.0, result is 4.5. Note that though the following statements give the same result 0, the statements are obtained differently. So k is equal to 2 divided by 9 and k is equal to 2.0 divided by 9. In the first statement, since both 2 and 9 are integers, the result 0 is an integer, that is 0, and this 0 is then assigned to k. So first statement, since both 2 and 9 are integers, so result is an integer, that is 0. So 0 is assigned to k. In second statement, 9 is promoted to 9.0 and then division is performed. Division yields 0.222222. However, this cannot be stored in k being an int here, hence it gets demoted to 0 and then stored in k. Hierarchy of operators. The priority or the precedence in which the operations in an arithmetic statements are performed is called hierarchy of operations. So it is about which operation will be performed first. So hierarchy is about the order of operations. Priority operators description. First priority is multiplication or modulus. So multiplication description is multiplication, division, modular division. So first priority is for multiplication, division, and then modular division. Now we will come to second priority. Second priority is plus is for operators plus minus, that is for addition and subtraction. So this is second priority. Now third priority is equal to, that is assignment operator. So third priority is for assignment operator. So first priority is for multiplication, division, and modular division. Second priority is for addition and subtraction, and third priority is for assignment operator. A few tips about usage of operators in general. A. Within parentheses, the same hierarchy as mentioned in figure is operative. Also, if there are more than one set of parentheses, the operation within the innermost parenthesis would be performed first, followed by operators within second innermost pair, and so on. So the same hierarchy is performed, that is first priority, second priority, and third priority. It will be performed. We must always, point B, we must always remember to use pairs of parentheses. A careless imbalance of right and left parentheses is a common error. So careless imbalance, that means imbalance of right and left parentheses, is a common error. Best way to avoid this error is to type two columns and then type an expression inside it. So best way to avoid this error is to type these two brackets and then type an expression inside that bracket. So most common error is a careless imbalance of right and left parentheses. All operators in C are ranked according to their precedence, and mind you there are as many as 45 odd operators in C. So there are 45 odd operators in C. Unfortunately, there are no simple rules that one can follow, such as BODMAS. So there are no such simple rules such as BODMAS, which is applied in mathematics. So BODMAS is a famous rule used in mathematics. So there is no such a simple rules like BODMAS that tells algebra students in which order does expression evaluate. So there is no rule such as BODMAS that tells algebra students in which order does expression evaluates. So there is no such rule in C. C can handle any complex expression with ease. Some of examples of C expressions are as follows. So C can handle many complex expressions with ease. Some examples are as follows: algebraic expression and C expression. So A into B into C. So algebraic expression A into B minus C into D. Now C expression A star B minus C star D. Now algebraic expression in bracket open M plus N bracket close bracket open A plus B bracket close. C expression bracket open M plus N bracket close star bracket open A plus B bracket close. Now algebraic expression 3x square plus 2x plus 5. So this is algebraic expression. Now C expression 3 star x plus 2 star x plus 5. So this is C expression. Now algebraic expression a plus b plus c in as a numerator, in denominator d plus e. So that is algebraic expression. And C expression is a plus b plus c slash d plus e. So we have to give brackets in C expression in this case. Now algebraic expression, C expression. So algebraic expression is square bracket 2by divided by, in denominator d plus 1 minus x divided by 3 in bracket z plus y. So bracket close. Now C expression is 2 star b star y slash d plus 1 minus x slash 3 star z plus y. So this is C expression. Associativity of operators. When an expression contains two operators of equal priority, the tie between them is settled using associativity of the operators. So when expression contains two operators of equal priority, then uh, if an expression has two operators, but they have first priority or second priority, they have equal priorities, so both are of first priorities, then there comes a tie between them is settled using the associativity of operators. Tie is settled using associativity of operators. Associativity can be of two types. First is left to right or right to left. So associativity can be left to right or right to left. Left to right associativity means that the left operand must be unambiguous. Left to right associativity means that left operand must be unambiguous. Similarly, in case of right to left associativity, the right operand must be unambiguous. Consider the expression a is equal to 3 divided by 2 into 5. So similarly, in case of right to left associativity, the right operand must be unambiguous. Now operator left right remark. So operator is divided by, left operator is 3 and right operator is 2 or 2 into 5. So remark left operand is unambiguous, right is not. In second case, star that is multiplied, then left operator is 3 by 2 or 2, right operator is 5. Right operand is unambiguous, left is not. Since both divided by and multiply have L and R associativity, and only divided by has an unambiguous left operand, necessary condition for left to right associativity, it is performed earlier. Operator left right remark. So operator is equal to left on is equal to sign left of is equal to sign uh, there is a on the right hand side b or b is equal to 3. So remark is left operand is unambiguous, right is not. And in second condition, operator is equal to on left b or a is equal to b, and on the right 3. So remark is right operand is unambiguous, left is not. Consider yet another expression, z is equal to a into b plus c divided by d. Here star n divided by enjoys same priority. So star n divided by have same priority and same associativity, that is left to right. Now operator left right and remark. So operator star that is multiplied by operator left right and remark. So operator is star that is multiplied by left operator is a, right is b, and remark both operands are unambiguous. Now divided by c d, both operands are unambiguous. Here since left operands for both operators are unambiguous, Compiler is free to perform multiplied or divide operation as per its convenience, since no matter which is performed earlier, the result would be same. So since left operand and both operators are unambiguous, compiler is free to perform multiplied or divide operation. Control instructions in C. As the name suggests, the control instructions enable us to specify the order in which the various instructions in a program. So they specify us the order in which the various instruction in program are performed, are to be executed by computer or performed by computer. In other words, control instructions determine the flow of control in a program. So these instructions determine the flow of control in a program. There are four types of control instructions in C. They are as follows. First is A, sequence control instruction. Second is B, selection or decision control instruction. Third is C, repetition or loop control instruction. And fourth is case control instruction. So these are four types of control instructions in C. Now first is the sequence control instruction. It ensures that instructions are executed in same order in which they appear in program. So the instructions are executed in same manner in which they appear in program. Decision and case control instructions allow the computer to take a decision as to which instruction is to be executed. So decision and case control instruction allow the computer to take a decision as to which instruction is to be executed next. So it is done by decision and case control instruction. The loop control instructions helps computer. So then the third is loop control instruction, to execute group of statements repeatedly. So loop control instructions are used uh, to execute group of statements repeatedly. Chapter 2, the decision control structure. So in this chapter we will discuss about making decisions. So these decisions have a structure. So this decision control structure means this decision making process has a structure in this language, so which is called the decision control structure. So we all need to alter our actions in face of changing circumstances. So alter means changing. We all need to alter our actions. That means we all need to change our actions in face of changing circumstances. That means as our situations or our circumstances change, we need to change our actions. If the weather is fine, then so that means if the weather is fine, that means weather is like, is it rainy or is it cloudy or is it sunny weather. So if the weather is fine, then I will go for a stroll. If highway is busy, I would take a diversion. So these are situations in we are changing our actions according to those circumstances. So in first circumstance, weather was fine. So this was for first decision, that weather is fine, then I will do a certain task. If highway is busy, I would take a diversion. So if highway is busy means this was second task, that highway was busy, so I would take a diversion. That means I am taking diversion. That means I am changing my action according to situation. That highway is busy is a situation and I am changing my action, that is I am taking a diversion. So it is change in action. Now if the pitch takes spin, we would win the match. If she says no, so if pitch takes spin, so this is another situation. So we spin a coin or we toss a coin in match. So if we are tossing a coin in match, we would win the match. That means, so this is a situation where we have to change our actions according to decision. Now she, if she says no's, I would look elsewhere. So this is a situation in life that if she says no, so she is saying no, and my change of action is I would look elsewhere. So I am looking elsewhere here. If you write this book, I would write, if you uh, write this book, or if you like this book, I would write next edition. So this is another situation in which we are changing our decisions or changing our actions according to situation. C language 2 must be able to perform different sets of actions depending on circumstances. So C language must be able to. So C language should be able to perform different sets of actions. So according to these changing situations, it has to perform different sets of actions depending on circumstances. So change in circumstance, reason, result in change in action. Now in fact, this is what makes it worth its salt. That means this is what is making worth its salt, means uh, this is what makes it unique or makes it important or makes it different. Now C has three decision making instructions. First is the if state. So it has a three major decision making instruction. First is the if statement, then the if else statement, and the switch statement. So these are three main decision making instructions. So there are few instructions in C language for making those decisions. So first is the if else statement, the if statement, then second is if else statement, and third is a switch statement. So these are three kind of instructions, or we can say three kind of commands, or three kind of features of this language. A fourth, somewhat less important structure is the one that uses conditional operator. So the statement or the structure which is using conditional operator is less important. In this chapter, we will explore all this way except switch, which has a separate chapter devoted to it later, in which a C program can react to changing some circumstances. So in this chapter, we are going to explore all this way. Uh, so we will discuss except switch, which has a separate chapter devoted to it later. So we are accepting switch here, in which a C program can react to changing circumstances. So we will discuss about, or we will explore the ways in which a C program can react to changing circumstances. Now decisions. So it is written so because decision because decisions, there is an exclamatory mark after decisions. So which shows that it creates a curiosity about, or curiosity, or decisions are shocking us. That means decisions make us shock. So decisions are important in our life. So in fact, to execute the instructions sequentially, we don't have to do anything at all. By default, the instructions in a program are executed sequentially. So in fact, to execute the instructions sequentially, we don't have to do anything at all. By default, instructions in a program are executed sequentially. So sequential execution is a part of C programming, or C structure. So execute these instructions sequentially. We don't have to do anything at all. They are automatically executed sequentially. Many of times we want a set of instruction to be executed in one situation, and an entirely different set of instructions to be executed in another situation. This kind of situation is dealt in C programs using decision control instructions. So many times we want set of instructions. So in one situation we need the program to react in a certain way, and in another situation we want that program to uh, react in certain way. So we use decision control instructions here for performing that certain task. Decision control instructions can be implemented in C using A. The if statement, B. The if else statement, C. The conditional operators. So decision control instructions are implemented in C. So it has a decision control structure, and these decision control instructions are implemented using some features, or what we can say, a certain elements, or certain things, or certain functions. So these are uh, three kind of things, or three kind of features of C language, or what we can say, C structure. So by using these features we can perform decision control. So first is the if statement, that is A, then B is the if else statement, and C is the conditional operators. Now the if statement. So this is first. Like most languages, C uses the keyword if to implement the decision control instruction. The general form, so like most languages, C uses the keyword if. So if keyword is used for implementing decision control instruction, and it is performed in many other languages also. The if statement. Like most languages, C use the keyword if to implement the decision control instruction. The general form of if statement looks like this. So this is general form of if statement. If in bracket this condition is true, then execute this statement. That means after if uh, the checking uh, condition checking or condition verifying is occurring. That means after writing if keyword, we are writing that if this condition is true, then we are executing that statement. The keyword if tells the compiler that what follows is a decision control instruction. So the keyword if is telling the compiler that what follows is a decision control instruction, and that means after if the decision control instruction will be executed. So that the keyword if is telling the compiler that the condition following the keyword if is always enclosed within a pair of parentheses. So the condition following the keyword if is always enclosed within a pair of parentheses. That means pair of the condition which is following if is enclosed within these brackets. If the condition whatever it is true, then the statement is executed. So if the condition if it is true, then the statement is executed. If the condition is not true, then the statement is not executed. Instead the program skips past it. That means if condition is not true, then statement is not executed. If it is true, then it is executed. So in first column, uh, this is expression, and in second column is true if. That means this expression is true if. So it is divided between two columns. First is x is equal to y. Then this expression is true if x is equal to y. That means for writing x is equal to y, we have to write x is equal to y. Now x uh, exclamatory mark is equal to y. That means x is not equal to y. So that exclamatory mark is an not operator. Now x is less than y. That means it stands for x is less than y. Now x is greater than y. So this stands for x is greater than y. Now x is greater than or equal to x is less than or equal to y. It stands for x is less than or equal to y. Now x is greater than or equal to y. This stands for x is greater than or equal to y. The relational operator should be familiar to you, except for equality operator is equal to and the inequality operator not is equal to. So the relational operator should be familiar to you. That means it is used in many mathematical calculations, that is x is less than y, x is greater than y. It is used in many mathematical calculations. So the relational operators should be familiar to you, except for the equality operator, that is equal to. So is equal to and inequality operator, that is not is equal to, are not familiar to us because they are not used in normal mathematics. Now note that is equal to is used for assignment, whereas is equal to is used for the comparison of two quantities. So is equal to is used for assignment, that means it is used for defining something. Is equal to is used for defining something, and 2 times is equal to is used for comparison of two quantities. Demonstration of if statement. Main, then int num. So main is basically function, so it is compulsory in every program. Now bracket open, int num, that is number is an integer, so int num. Printf enter a number less than 10, semicolon. So here we are telling that the compiler to enter a number which is less than 10. Now scanf. So here we are scanning that number. So %d. So %d is written because that number is an integer. So %d, comma and num. So ampersand is ampersand, and ampersand is given before any integer or any quantity. So scanf %d, comma and number and num. Now if num is less than or equal to 10, so here it is comparing num with 10. Now printf what an obedient servant you are. So here we are printing that you have entered a right number which is less than 10. So it is a demonstration of if statement. So this was program for demonstration of if statement. So first we entered a number which is less than 10. Then we scanned that number using %d and ampersand num command, that is scanf function. Then we compared that number. We verified that is number is less than 10, and then we printed what an obedient servant you are. That means your number is right now. that we have printed. Now we will look at flowchart. So this is flowchart of this program. First we are starting, so start is written. Then arrow is pointed to print enter a number less than 10. So here we are printing that enter a number which is less than 10. Now arrow is pointing towards input num. That means input num means we have to enter that number and receive that input of that number. Now arrow is pointing toward is number is less than 10. So is num less than 10. So then arrow is pointing to yes or no. So there are two conditions, that is yes or no. Then if yes, print what an obedient servant you are, and if no, then stop. So this is basically flowchart. So after starting, we are printing enter a number less than 10. Then we are giving input of that number. That means we are receiving or perceiving input of that number. Now is number less than 10 or greater than 10. So we are comparing that number with an integer 10. Now we are if it is we are checking if it is yes or no. So if it is yes, we are printing what an obedient servant you are. That means you have entered a correct number. So that is we are printing. And if no, then we are stopping this program. So this was flowchart of demonstration of if statement. Example 2.1. While purchasing certain items, a discount of 10% is offered. So this is first statement, that is while purchasing certain items, a discount of 10% is offered. Now if quantity purchased is more than 1000, if quantity purchased is more than 1000, if quantity and price per item are input through keyboard, write a program to calculate total expenses. That means first statement is while purchasing certain items, a discount of 10% is offered. That means when quantity is more than 1000, then discount of 10% is being offered. Now if quantity and price per item are input, so we have to input this quantity and price, and so we have to calculate the discount. We have to calculate total expenses. So this was problem statement. So we will draw a flow chart in order to find solution of this problem. So first is start, then after start arrow is pointing towards dis is equal to 0. That means initially discount will be equal to 0. So dis stand for discount, so d is equal to 0. Then after this block arrow is pointing towards input quantity comma rate. That means inputs are quantity and rate, these are inputs. Now arrow is pointing towards quantity is more than 1000. So here in input we are taking, that is we are scanning quantity and rate. So we are giving input of quantity and then rate. Now we are comparing is quantity is more than 1000. So comparison is being done. Now there are two options, that is yes and no. So if yes, discount is equal to 10. So this is equal to 10, that means discount is equal to 10 if yes. and if no, then the arrow is proceeding further. So until this point, first we are starting, then we are giving this is equal to 0, that is initial discount which was equal to 0. Then we are scanning inputs which are quantity and rate, so we are scanning them. Now we are considering if input quantity is more than 1000. Now if no and if yes, there are two options, that is no and yes. So is quantity is more than 1000, yes, then discount is equal to 10, which was 10%. So this is equal to 10. Now we are proceeding further. Now we have discount. Now we are proceeding. Now in this next block, which is square rectangle, we have formula for calculating the discount, that is TOT, that is total, is equal to quantity, QTY is quantity, star, that is multiplication, total is equal to quantity multiplied by rate, minus quantity star, that is multiplied by rate, star, that is multiplied by discount divided by 100. So this was formula for calculating total price. So after this formula is performed or operation is performed, the arrow is pointing toward print, that is print tot, that means we are printing total. Now stop, then arrow is pointing towards stop. So again we will see this flow chart. First it was start, then there was this, that is 0, then there was input quantity and rate. So first it was starting, then initial this, that is discount was 0, so this is equal to 0. Now input was quantity comma rate, so input were quantity and rate. Now is quantity is more than 1000, so if it is comparing that if quantity is more than 1000 or not. So no and yes are there. So for yes discount is 10 and for no discount. Now total, now then there comes a formula, and by applying this formula we are printing total result, and then we are stopping. Calculation of total expenses. So this is program for a problem statement. So this is first line is comment, that is calculation of total expenses, this is comment. So for opening comment we write slash, then star, then we write comment, then for closing comment we write star and then slash. Then first line of program is main. So main is a function which is by default it is a compulsory, and then bracket is opening. Now after bracket open, int qty comma dis is equal to 0. So so we are defining here that qty, that is quantity, and dis is equal to 0, that is discount, are two integers. So initially discount was equal to 0 initially. So integer quantity and discount is equal to 0 is written. Now float rate tot, that is quantity and discount are integers, and rate and total quantity are float. So float rate comma tot, that is rate and tot are float. Now printf function is given, enter quantity and rate. So here we are printing that please enter quantity and rate. So this will be printed on screen, that enter quantity and rate. Now bracket close and semicolon. After that we are scanning those quantities. So first we will scan qty, that is quantity, and then we will scan rate, that is float. So scanf in inverted commas %d %f then inverted comma complete, then and qty, ampersand qty and ampersand rate. So scanf percent d, because quantity, that is qty, is an integer, so percent d is written. Now ampersand rate, that is percent f, so rate was in float, rate was float, so float is written here. Now if quantity is more than 1000, so if loop starts here. So until this point, first we have mentioned quantity and discount as integer. Discount is equal to 0, those were integers. Now then we mentioned rate and tot were float. Now then we entered, please enter quantity and rate, and then we scanf, with help of scanf we scan those quantities. So up till until scanf, this quantity and rate are scanned. Now we are performing calculations. If quantity is more than 1000, so we have quantity now, that is qty now. So if qty is more than 1000, discount, that is this, is equal to 10. So if qty is more than 1000, then this is equal to 10, then semicolon. Now tot is equal to, so here we are comparing. Now this is equal to 10, so we are adding if statement here. If quantity is more than 1000, then discount is equal to 10, so discount is 10%. Now the formula part is starting here, that is tot. So formula part is tot is equal to, in first bracket qty star rate bracket close, in second bracket qty star rate star this divided by 100. So here that formula part is complete. Now printf. So now we have total, that is tot is stored in some memory location. After this we are typing printf, that is total expenses is equal to percent f tot, because tot is total expenses is equal to rupees percent f comma tot, because tot is a float, so we are writing percent f here. So in example 2.1, in first run of program, the condition evaluates to true as 1200. So if we enter quantity 1200, so as a input to this program, then this condition can evaluate to true as 1200, that is value of quantity is greater than 1000. So 1200, that is 1200, is greater than 1000. So it is evaluating, or it is verifying that condition of that program. So if we enter 1200, it can what we can say, verifies, or it can evaluate that condition of that program. Therefore the variable dis, that is dis, therefore the variable dis which was earlier set to 0, hence the variable dis which was earlier set to 0, that means it was set to 0, now gets a new value 10. So the variable dis which was earlier set to 0, now it gets a new value 10. So if the quantity is less than 1000, then this will be equal to 0, and if quantity is more than 1000, then this will be equal to 10. So after entering 1200, this will get value 10. Using this new value, total expenses are calculated and printed. So using this new value, total expenses are calculated and they are printed. So this program was about if statement, that is calculating or taking decision with respect to value entered. So and applying changes in calculations, that is 0% discount or 10% discount. It was about applying changes in the calculation. So a new value of total expenses are calculated and printed. So this was an example of if statement. Multiple statements within if. So in this topic we will be discussing about if statement, but in multiple format, that is multiple statements within if. That means more than one statement in an if statement. So it may so happen that in a program we want more than one statement to be executed if the expression following if is satisfied. So it may happen that in a program, so in a program it can happen that we want more than one statement. That means we want multiple statements to be executed if the expression following keyword if the expression following keyword if is satisfied. So the if the expression following keyword if is satisfied, if such multiple statements are to be executed, then they must be placed with a pair of. So if such multiple statements are to be executed, then they should be kept within pair of braces. So if multiple statements are to be executed, then they should be kept in a pair of braces. So example 2.2, the current year and the year in which the employees joined the organizations are entered through keyboard. So some input is given to keyboard, which is the current year and the year in which employee join. That means current year's input and the year in which the employee join in the organization are entered through keyboard. So the year in which employees join. Now if the number of years for which the employee has served the organization is greater than, a bonus of 2500 is given to employee. So if the number of years for which employee has joined the organization is greater than some year, so a certain year like 3 year or 4 year. So if number of years for which the employee has served the organization is greater than certain years, then a bonus of rupees 2500 is given to that employee. So the bonus is given to that employee. If the years of service are not greater than 3, then program should do nothing. That means if years of service are greater than 3, then the bonus of 2500 should be served, and if not, the bonus should not be served. So this is a statement about giving a bonus of rupees 2500. Now we will discuss about flowchart. So this is flowchart for statement. So first block is start. So after start, arrow is pointing to input CY, then YOJ. That is CY is current year and YOJ is year of joining. So input is given through keyboard, that is current year and year of joining. Now the arrow is pointing towards year of service, which is CY, that is current year minus year of joining. So that is year of service, so which is calculated. Now it is comparing in this block, that is year of service is greater than 3, then if is it yes or is it no. So if it is no, then program will stop, and if it is yes, then bonus is equal to 2500. That means bonus is added. Now print bonus, and uh, now we are printing bonus and we are stopping. So this is flowchart of this statement, problem statement. So this is a program for example 2.2. So first line is comment. So for opening comment we know that we are writing first slash, then star, then we write comment, that is calculation of bonus, then star, then slash. So first line is comment. Now second line is main. So main function is compulsory in every program. So after main function, this loop starts. Loop, not loop actually, it is a bracket. So here bracket is starting. Now next line is int bonus comma cy comma yoj comma yr of ser and semicolon. So bonus cy yoj and year of ser, these are all integers. Now so here we are defining that these are integers. So this line was about defining of those integers. Now printf, enter current year and year of joining. So here we are asking for of asking to user that enter current year and year of joining, that is enter current year, that is cy, and year of joining, that is yoj. So printf, so we will print on screen that enter current year and year of joining. Now so this line was about printing current year and year of joining. Now scanf %d ampersand cy ampersand yoj. So %d is written because cy and yoj, ampersand cy and ampersand yoj are integers, so that is why %d is written. Now yr of ser is equal to cy, that is current year, minus yoj, that is year of joining. So year of service is equal to current year minus yoj. Now if so after scanf, so we have taken value of cy. So until scanf we have taken value of cy, that is current year, and yoj, that is year of joining. So we have those values, that is current year and year of joining, we have those values. Now after getting those values, so yr of serve, that is year of service. So year of service, so year of service is calculated by current year minus year of joining. So this line is about finding year of service. Now we have found year of service. Now we will compare that year of service. If in bracket year of service, that is ser, is more than 3, so here if statement is starting, that is year of service. So if year of service is more than 3, then in bracket bonus is equal to 2500. So we had defined previously that bonus was integer, so we can directly write bonus is equal to 2500. Now printf bonus is equal to rupees %d comma bonus. So we are printing that bonus is equal to rupees %d percentage because it was integer, then bonus. So we will print here bonus is equal to rupees 2500, and here we are closing brackets. So first closing bracket is for if statement, and second closing bracket is for main loop. So this is a program. In example 2.2, observe that here the two statements to be executed on satisfaction of condition have been enclosed within pair of braces. So in that program, two statements to be executed on satisfaction of condition are in within they were within pair of braces. That means main function was in one parenthesis, and if function was in one parenthesis. So here we can see in last and second last line there are two brackets, there are two closing parentheses or braces. So first last parenthesis is for main function, and second last parenthesis is for if function. If a pair of braces is not used, then C compiler assumes that the programmer wants only the immediately next statement after the if to be executed. So there are two pair of braces. So if it was not it is not used, so pair of braces, if they are not used, then C compiler will assume that the programmer wants statement written after if keyword immediately. So that's why these braces are important. So next statement, so after the if to be executed on satisfaction of condition. So this so in other words we can say default scope of the if statement is the immediately next statement after it. So default scope of if statement is performing immediately next statement which is after it. So default scope of if statement is that it performs or acts on next statement which is immediately after it. Now the if else statement, so this is another kind of function, or we can say another kind of part which is used for decision making process, the if else statement. The if statement by itself will execute a single statement. So by itself if statement will execute a single statement or a group of statements when the expression following if evaluates to true. That means when that condition is satisfied. For example, if it is comparing with something, so if it is greater than that number, or if that condition is satisfied, then the if statement by itself will execute a single statement or group of statements which are written after it. If that statement evaluates to true, it does nothing when expression evaluates to false. So the drawback, this is drawback of if else if statement, that it is evaluating or performing expression uh, when uh, when that condition evaluates to true, but it does nothing when expression evaluates to false. So when that expression evaluates to false, the program stops in if statement. So this is drawback of if statement. So to recover that drawback, this if else statement is used. So we will understand more about if and else statement. So sometimes there are two conditions in which we have to perform different action for true and false evaluation. So in those conditions this statement called the if else is useful. So this is an example for if else statement, so which is a conditional operator. So we will start this. In a company, an employee is paid under as follows. So in a company, employees are paid, and we are discussing about it. If his basic salary is less than rupees 1500, so if his basic salary, so employee has different sections in salary, that is basic salary, then he is like a car allowance or washing allowance, or what we can say, there are different allowances with basic salary. So if his basic salary is less than rupees 1500, then HRA is equal to 10% of basic salary. So HRA is one of that allowance. So then HRA is equal to 10% of basic salary, and DA is equal to 90% of his basic salary. That means HRA and DA are 10 and 90% accordingly if his basic salary is 1500. Now next statement. If his salary is either equal to or above rupees 1500. So if it is equal to 1500 or above 1500, then HRA is equal to rupees 500 and DA is equal to 98% of his basic salary. So this is second statement. If his salary is either equal to or above 1500, then HRA is rupees 500 or rupees 500 and DA is 98% of his basic salary. This was second statement. Now third statement. If the employee's salary is input through keyboard, write the program to find his gross salary. So we have to make a program in which we have to use scanf function. So if employee's salary is input through keyboard, write a program to find his gross salary. So we have to find a program in which we find employee's gross salary. So this is flowchart for the statement. So first block is start, then the arrow is pointing toward input BS, that is we have to take input BS is basic salary. Now we have to take input from user or employee or the person who is entering data through keyboard. So we have to take input from him. Now input BS, that is we have to uh, take input of basic salary, that is BS. So then it is pointing to is BS is less than 1500. So this is conditional statement, that is if else. Now we have BS which was taken as an input. Now we are comparing it with number 1500. Is BS, that is basic salary, is less than 1500. So if it is less than 1500, then HRA, so in right hand side we have a block in which HRA is equal to BS, that is basic salary, into 10 divided by 100, and then the arrow is pointing towards DA is equal to BS into 90 divided by 100, which is 90% of basic salary, and HRA is equal to basic salary into 10% of basic salary. So if it is less than 1500, if BS is less than 1500, then HRA will be 10% of basic and DA will be 90% of basic. Now if not, if BS is not less than if BS is not less than 1500, then HRA is equal to 500 and DA is equal to basic salary into 98%. So both inputs are given to GS is equal to, so this is a formula for gross salary. So the gross salary GS is equal to BS, that is basic salary, plus HRA plus DA. So gross salary equal to basic salary plus HRA plus DA. Now we have to print gross salary. So here we have gross salary saved. Here we have gross salary saved and we have to print it. So we are giving print gross salary, that is GS, and then finally stop. We are stopping. This is program for the if else statement problem. So this is after flowchart. We are writing this program. So first line is comment. So it is calculation of gross salary. So that is comment. Then main. So this is a compulsory function. Now the loop starts. Not loop, but the bracket is starting. Now third line is float BS comma GS comma DA comma HRA and semicolon. So BS GS, that is basic salary, gross salary, DA and HRA. So these are floats because they have decimal point, so they are float. So we are defining that these are floats. Now printf. So now we are printing enter basic salary. So printf enter basic salary semicolon. So here we are asking user that to enter that BA, that is basic salary. Now scanf %f, that is float, comma ampersand BS and semicolon. So scanf %f comma ampersand BS. So which is float, BS is float. Now if BS is less than 1500, so if BS is less than 1500, then that loop starts that HRA is equal to BS star 10 into 10 divided by 100, so 10% of BS. So in if statement, basic salary BS is less than 1500, so in bracket HRA is equal to BS, that is basic salary, multiplied by star, that is multiplied 10 divided by 100, so 10% of basic salary. Now DA is equal to basic salary multiplied by 90 divided by 100, so 90% of basic salary. Now the else statement starts. So else ELSE, then that bracket again is opening. HRA is equal to 500. So this is else statement. So HRA is 500 semicolon. Then DA is equal to BS, that is basic salary, star, that is multiplied by 98 divided by 100 and semicolon. So DA is basic salary, 98% of basic salary. Now we have both these statements, that is if statements we have written and else statement also we have written. So in if statement there were certain conditions like HRA was 10% of basic salary and DA was 90% of basic salary. So in if statement it was like this, and in else statement HRA was 500 and DA was 98% of basic salary. So that was in else statement. So if and else statement part is now completed. Now gross salary, that is GS. So gs is equal to, in next line we are writing gs is equal to bs plus hra. So bs plus hra plus da. So this is a formula, or we can say um, that is a addition of basic plus hra plus da, that is gross salary. Now we have gross salary stored as a float. Now we have to print that gross salary. So for printing we do printf function. So printf gross salary is equal to rupees dot percent f comma gs, that is printf gross salary. So we are printing gross salary, that is percent f because it is float. So we are printing gross salary comma gs because gs is gross salary. And now that bracket is closed, which was a bracket of main function, so it is closed. And that is the whole program. A few points worth noting in a gross salary program, that is if else statement program. Point A: the group of statements after if up to not including the else is called if block. So there is an if block. So in the if block, the group of statements after the if up to not including else is called an if block. So there is an if block. Similarly, the statements after the else form the else block. So statements before else form if block, and statement after else form the else block. As with the if statement, the default scope of else is also statement immediately after else. So after if statement, the default scope of else is also there. Default scope, that means default execution after of else is so default scope of else is also the statement immediately after else. So what statement we are writing after the else command, it is a default scope after the else. Now nested if else's, it is perfectly alright if we write an entire if else construct within either the body of if statement. So it is perfectly alright if we write an entire if else statement construct within either the body of if statement or the body of else statement. This is called nesting of if else. That means we are putting if else statement within if statement, so which is called nested if else's. So a quick demo of nested if else. So we are putting if else statement within an if else statement, which is called as nested if else statement. This program is for a quick demo of nested if else. Main, this is a function which is compulsory. Then the bracket is opening. Now int I, that is I is an integer. So this program is for a demo of nested if else statement. So I is an integer, we are defining it as integer. Now printf enter either 1 or 2. So we are telling the user that enter value 1 or 2. Now scanf %d comma ampersand I, that is we are scanning that value which is taken from user. %d is written because it is percentage written because ampersand I is an integer, so %d is written. Now if I is equal to 1, so this is 2 times is equal to is a relational operator. So if I in bracket I is equal to 1, printf, so it is comparing that I with 1. Now printf, you would go to heaven. So if 1 is entered by user, printf you would go to heaven, and then close. Now else, in bracket, if I is equal to 2, printf hell was created with you in mind. So if I is equal to 2, so we are comparing I with 2. So if I is 2, then printf hell was created with you in mind. So it is for 2. Now else, printf how about mother earth. So else, printf how about mother earth. So this is an nested if else kind of statement. So first part was if part, if I is equal to 1, then else do I is equal to 2, then else print how about mother earth. So this was a quick demo, or a demo of nested if else statement. So in a nested if else program, note that the second if else construct is nested in first else statement. So there are two statements in which one statement is nested or is put into or is attached with the first else statement. So if the condition in the first if statement is false, so if the condition in first if statement is false, then the condition in second if statement is checked. So condition in second statement is checked. If it is false as well, then the final else statement is executed. So the conditions are executed according to the evaluation sequence. That means if the if first if statement is not evaluated or is false, or is not according to some guideline, or it is false, or it should not be executed, then the second statement will be executed. And then if that second statement is not also proper according to the guideline, then the final statement will be executed. That means the statements will be executed until that program is finding the proper statement which is according to our conditions. So uh, that is how the structure of nested if else is. You can see in the program how each time if else construct is nested within another if else construct. So uh, the first if else construct is nested within another if else construct. It is also uh, indented to add clarity to program. So so both the statements are added into one another. Now in above program, an if else occurs within the else block of first if statement. Similarly, in some other program, an if else may occur in the if block as well. There is no limit on how deeply if and else's can be nested. So this is an important part, that there is no limit that how deeply this if and else's can be nested. So there can be multiple if else statements in one program. Forms of if statement. The if statement can be take any of the following forms. So these are few forms of in which if statement is written or it is explained. A, if condition then do this. So this is first form, that is form A. If then condition is written and then do this. Now B, if then we write condition, then in bracket we write do this and this. So this is second form, do this and this is form B. Now third is condition C. If then we write condition, then do this, else do this. That means this is form C, this is third form. So if, then we write condition, then do this, else do this. So else is there. Now D, form D. In this form we have if, then we write condition, then do this and this, else do this and this. So this is form D, that is fourth form. This is form E. In this form, if is written, then condition is written, then do this, then else. If condition is written, then do this, else do this and this. So this is form E, this is fifth form. So here there are multiple conditions are written and else also is written. So form F, if condition is written, then if condition do this. So here also there are two conditions are written. If condition, then in bracket if condition, then do this, else do this and this, else do this. So this is sixth form, that is form F of if else statement. Use of logical operator. So this section is about logical operator. So we have seen if else statement and nested if else statements. So in nested if else statements, we can put many statements in one. That is, the possibilities are endless in if else statement. Now we are discussing use of logical operator. So first point is C allows usage of three logical operators. So C language is allowing usage of three logical operators, namely and, or, and not. So these are three logical operators. First is and, that is for and operation. Then or, that is for or operation, and not, this is for not operation. So basically these logical operators are derived from logic gates. So you can search for logic gates, that is and gate, then or gate, and then not gate. So these are to be read as and, or, and not respectively. So these are to be read as and, or, and not respectively. Now so there are three logical operators. Now there are several things to note about these logical operators. So there are several things to note about these logical operators. Most obviously two of them are composed of double symbols, or, and. So two of them are, that is and or, are composed of double symbol, that is and or. Don't use the single symbol or and. These symbols have different meaning. So or and, so these symbols have different meanings. So we don't have to use single symbol. So the first two operators and or allow two or more conditions to be combined. So first two operators, that is and or allows two or more conditions to be combined in an if statement. So in an if statement, and or allows two or more conditions to be combined. So this is for and or operators. So this is example about logical operators. The marks obtained by a student in 5 different subjects are input through keyboard. So there are there are marks in 5 subjects which are needed to be input through keyboard. The student gets a division as per following rules. So division means the group in which student will belong. So that is division. Now the student is entering marks of 5 different subjects and through keyboard, and he gets a division, that means his group, according to following rules. So we have to make a program for that. So these are rules, or this is data. So first is percent above 60. This is first division. That is first group. Now percent between 50 and 59. It is second division. So first division was for above 60. Now in between 50 to 59, second division. Then a percentage between 40 and 49 is third division. 40 and 49 is third division. Now percent less than 40 is fail. So these are divisions. Write a program to calculate the division obtained by student. So we have to write program. So there are two ways in which we can write a program. For this example, these are methods given below. So there are two ways in which we can write this program. So first is method 1. So in first line main is written, so this is main is compulsory function. Then bracket is opening. Now int m1 m2 up to m5 and per, that is per is percentage. So m1 to m5 and per are integers. Now so they are defined first. Then printf enter marks in 5 subjects. So we are telling user to enter marks of 5 subjects. Now scanf, that is percent d percent d percent d percent d percent d, because all are integers, so percent d. Now ampersand m1 up to m5. So we are scanning those marks. We are telling user to enter those marks of 5 subject. Now we are scanning those marks. After scanning, so we have data of 5 marks. Now we will do calculations. Now per, that is percentage, is equal to m1 plus up to m5. So all these are added and divided by 5, that is average. So percent is equal to, so because all marks were out of 100, so the per is equal to percentage is equal to addition of all marks divided by number of subjects, that is 5. Now we have value of per, which is saved in integer per. Now we are comparing with if per is greater than or equal to 60. So we have first that data. If per is equal to is greater than or equal to 60, printf first division. So here we are using if else statements. So if percent is greater than or equal to 60, then first division. Else if else if, so if else if, that statements are given. Else if percentage is greater than 50, then print second division. If percentage greater than or equal to 50, then second division. Else if percentage is greater than or equal to 40, then third division. Or else printf fail. So and then 3 are closing brackets. So this program is about using if else statement for this calculation. This is a straightforward program. Observe that the program uses nested if else's. This leads to 3 disadvantages. So this program was using nested if else's statements and it was complicated. So this is, it is complicated and it has a disadvantages also. So we solved a program of example 2.4 with help of if else statements. So they were nested if else statements, but use we can use as many if else statement as we want, but it has something drawbacks. So those drawbacks are as follows. So drawback A is, as the number of conditions goes on increasing, that means as number of conditions, that means there can be a lot of number of conditions. So as number of conditions goes on increasing, the level of indentation also goes on increasing. So the level of indentation, that means level of complexity and all, it goes on increasing. As a result, the whole program creeps to right. That means the whole program becomes complex or complicated. As number of conditions goes on increasing, the program becomes complicated. So now point B, care needs to be exercised to match the corresponding if and else's. So care needs to be exercised, that means to match corresponding if and else's. That means uh, to that means we have to take care of those if and else's. So we have to open brackets properly, close brackets properly. So the care needs to be exercised to match the corresponding if and else's. Now C, care needs to be exercised to match corresponding pair of braces. So care should be taken for matching corresponding pair of braces. That means to match, that means pair of braces should be entered correctly and care should be taken for that also. So all these three problems can be eliminated by usage of logical operators. The following program illustrates this. So all these problems can be eliminated by using of logical operators. So this is method 2 for solving example 2.4. So first is main. So this is a compulsory function. Then bracket is opening. Now int m1 up to m5, then per, that is percentage. Now printf, enter marks in 5 subjects. So we are asking user to enter marks of 5 subjects. Then scanf %d because all marks are in integer. Now we scan this marks. Now per is equal to sum of all these numbers divided by 5. Now if so, now we have per, that is percentage value. Now we will be using logical operators. If per is more than or equal to 60, printf first division. Now if per in bracket per is greater than or equal to 50 and per is less than 60, printf second division. So here we used and operator. If per is more than or equal to 50 and per is less than 60, then printf second division. Now if per is more than or equal to 40 and per is less than 50, printf third division. Now if per is less than 40, then printf fail. So here in this program we have used logical operator and. So for defining if percentage is between 50 and 60, we used and thus we printed second division. To define the is per percent value is between 40 and 50, we used per 40 and per 50, and we wrote third division. So we used logical operators. As can be seen from second if statement, the and operator is used to combine two conditions. Second division gets printed if both conditions evaluate to true. That means from second if statement we can see that and operator is used to combine two conditions. That is percentage is between 50 and 60. So it used and operator to combine two conditions, and thus we wrote second division got printed. Thus we wrote second division if both condition evaluates to true. If one of the condition evaluates to false, then whole thing is treated as false. That is, we will print So that whole thing will be treated as false. So and operator is used for is being used for that purpose. In example 2.4, which was using logical operators, that is AND operator, there are two distinct advantages and they can be cited in favor of this program. So there are two advantages which can be cited in favor of this program. A, the matching, or do I say mismatching of the ifs with their corresponding else's. So matching or mismatching of the ifs with their corresponding else's gets avoided since there are no else's in the program. So using and when we are using a logical operator, that is AND operator, then there are no else's in program. So there are only if in program. So this is one of advantages. So this is advantage A. Now advantage B. In spite of using several conditions, the program doesn't creep to the right. So in spite of using several conditions, the program is does do not look or is not looking complex. So that means it creeps. That means program, in spite of using several conditions, the program doesn't creep to the right. So in the previous program, the statements went on creeping to right. That means a lot of statements were used. That is, if else statement were used in previous program. So this effect becomes more pronounced as number of conditions goes on increasing. So this effect becomes more pronounced. That means programs becomes too much complex as we are continuously using if else statement. So this is another advantage. Now the else if clause. So we are using the same program using else if clause. So we are using logical operator as well as else if clause now. So else if ladder demo. So this is program for else if using else if statements. So first is main. This is compulsory function which is used in every program. Now int m1 up to m5 and then per. So m1 to m5 and then pr per, these are integers. So they are specified as integers. Now per is equal to m1 to m5, addition of all m1 to m5 divided by per, divided by 5 actually. Now if per is greater than or equal to 60, printf first division. Else if, so if percent is greater than or equal to 60, then we print first division. Else if percentage equal to percentage is greater than or equal to 50, then print f second division. Else if percentage is greater than or equal to 40, else print f third division. Else print fail. So here we are using else if clause or else if ladder. You can note that this program reduces the identification of the statements. In this case, every else is associated with ifs, its previous if. So in this program, every else is associated with its previous if. So it is reducing the identification of the statements. So it is else if ladder. The last else goes to work only if all the conditions fail. Even in else if ladder, the last else is optional. So else and if are connected in this else if ladder program. Note that the else if clause is nothing different. It is just a way of rearranging the else with if that follows. This would be evident if you look at following code. So else if program is same, uh, but it is rearrangement of the if and else's. So this rearrangement can be noticed with the following programs. So if I is equal to 2, print f with u, else if j is equal to 2, print f all the time. So this is one way of writing. Now if I is equal to 2 is equal to 2, print f with u, else if j is equal to 2, print f all the time. So program on the left hand side and right hand side is same, but the arrangement is different. That is else if written, else if is written, so arrangement here is different. Another place where logical operators are useful is when we want to write programs for complicated logics that ultimately boil down to only two answers. So another place where logical operators are useful when we are writing a more complicated programs, so they are useful. Otherwise else if statements can work for us, but there are some programs which have more complicated logics. So there in those programs else if logical operators are useful. Example 2.5. A company insures its drivers in following cases. First, if driver is married. Second, if driver is unmarried, male, and above 30 years of age. Third, if driver is unmarried, female, and about 25 years of age. So this is an example of company insuring its driver. So this is program for example, insurance of driver without using logical operator. So this is program for that is without using logical operator. So in this program we will come to know that without using logical operator, program becomes a lot of lengthy. So that is problem with not using logical operators. So first is main. So main is a compulsory function which is used in every program. Now bracket is open. Now opening bracket. Now char sex comma ms. So sex and ms are characters. Now int age. So age is an integer. Here in first two lines we are defining some characters and then integers. Now printf, enter age, sex, marital status. So we are telling user to enter these following things. Now scanf, %d, %c, %z, %d, %c, comma, ampersand age, ampersand sex, ampersand ms. So here we are telling user, telling compiler to notice or to understand these entered values or entered characters. So we are making compiler notice using scanf function. %d is used because age is integer and %c is used for both these remaining characters. So %c is for character and %d is for integer. Now we are comparing, that is if ms is equal to m. So is equal to is equality operator. So if is a condition. Now if ms, that is marital status, ms is equal to that means ms is equal to capital M. So marital status is equal to capital M. So here first we are discussing about marital status, that is male or female. So hence we are writing if ms marital status is equal to male or female. Now printf, driver is insured. That means if marital state we are getting, after getting marital status, we are printing that if driver is insured. Else, if sex is equal to male, if age is more than 30. Now if sex is equal to m, if age is more than 30, then printf driver is insured. So else printf driver is not insured. So here we are using nested if else statements. So first we are comparing if sex is equal to m, that is first we are discussing about is it male and is its age is more than 30, then print driver is insured, or else print driver is not insured. Now if age is more than 25, so here if else loop is completed. Now again we are adding one if else loop, that is for age 25. If age is 20 more than 25, printf driver is insured, else printf driver is not insured. And here we are closing all three brackets of if else statement, and this program is finished here. But with the help of this program, here we are understanding that it is very tough or difficult to write such a program with if else, only if else statement. So program becomes lengthy, and without using if else, without using logical operators, it becomes difficult to write such programs without using logical operators. So from this program we understand that so logical operators are also important for making program compact. From example 2.5, which was without using logical operators, from that we know that, or it is evident that we are required to match several ifs and elses and several pairs of braces. That means we have to use nested if else statements. So we can use nested if and else statements, but we have to use several of them. That means too many of them. So from the program it is evident that we are required to match several ifs and elses and several pair of braces also. So it can be complex. As mentioned above in this example, we expect the answer to be either driver is insured or driver is not insured. So the answer expected was uh, is he insured or is not insured. So that is why we were using if else statement. Now if we list down all those cases in which driver is insured, then they would be: A. Driver is married. B. Driver is unmarried male above 30 years of age. C. Driver is unmarried female above 25 years of age. That means these were conditions. Since all these cases lead to the driver being insured, they can be combined together using an or operator as shown in program below. So now we will understand program in which we are using logical operators. So same example as 2.5 we will be doing with logical operator, and we will understand differences. So first line is main, which is compulsory, then char sex ms int age. So age is integer and these sex and ms are characters. Now we have defined that. Now printf enter age, sex, marital status, etc. So we are asking the user to enter these things, so which was same as example 2.5. Now scanf %d %c %c. So we are scanning those things. So %d is for integer, %c is for character. Now if Now here the logical statement part is starting. Now if ms is equal to m, that means it is uh, comparison, it is an equality. So is equal to is operator. So ms, that is character ms, is capital M, then or, that is logical operator or, ms is equal to u, that is unmarried, and sex is equal to m, and age is more than 30, or ms is equal to unmarried, and sex is equal to f, and age is greater than 25. So here in this one sentence we did all of the calculations, that means we did all of the comparisons. So we don't have to use if and else statement again and again repeatedly. So here we have used or and or and. So these logical operators are used here. So printf driver is insured, else printf driver is not insured. So here we are giving that is it insured or not insured. So in one if statement or if sentence we have mentioned all of the conditions, that is marital status should be married, then or it can be unmarried and it can be male, and age should be less more than 30. So all of these have mentioned within logical operators. In this program, it is important to note that driver will be insured only if one of the conditions enclosed in parenthesis evaluates to true. That means a driver will be insured only if conditions are true. So those were the given conditions. So if it is true, then it will evaluate. For second pair of parentheses to evaluate true, each condition in parenthesis separated by and must evaluate to true. So or is used in first condition, and is used. So from this example we know that using logical operator is always beneficial because it requires a less complexity. So it is always beneficial than using if else statement, if a nested if else again, a loop again and again. Even if one of the conditions, so in the previous example in 2.5 we seen that using logical operator is always easy as compared to nested if else. So nested if else can be used how many times or many times that we want, but it can create a mess, or it can uh, increase complexity of program. So use of logical operators is always helpful. Now even if one of the conditions in second parenthesis evaluates to false, then the whole second parenthesis evaluates to false. So we can conclude that using of logical operators such as and or are useful in only useful in following programming situations. A, when it is to be tested whether a value falls in a particular range or not. So when value is under between a particular range, so in this case these and or logical operators are can be useful. Then B, when after testing several conditions the outcome is only one of two answers, this problem is often called yes no problem. So when a yes no problem is there, that means when after testing several conditions the outcome is only one of two answers. So when it is either 0 or 1 or true or false or yes or no, so in those conditions these logical operators can be very helpful. Example 2.6, write a program to calculate salary as per following table. So this is an example in which we are performing different tasks. So we can use logical operator for this. So this is basically a data from which we have to make a according program. First is gender, then year of service, qualification and salary. So there are two sections for male and female. For a male section, for more than or equal to 10, then post graduate, and there is salary of 15,000. Now more than uh, more than or equal to 10, then graduate, then 10,000, then more than 10, then postgraduate, that is 10,000, then more than 10, graduate, 7,000. So this is male section. Now there is a female section, more than less than or equal to 10, postgraduate. So basically this is data according to which we have to make program. Now for graduate 9,000, then for less than or more 10, postgraduate 10,000, and for more than 10, graduate, that is 6,000. So basically this is data. Now we will look at program. Now main, this is compulsory function for every program. Now char g, that is gender. Now int is equal to bios qual, then sal. Now printf enter, year of service, qualification and salary, these are integers. Now printf. So here we are telling the user to enter following conditions, that is enter gender, years of service and qualification, that is 0 for graduate and 1 for postgraduate. So here we are telling user to enter all those things. Now scanf. Scanf is %c, %d, %d, ampersand g, ampersand yos, ampersand qual. So here we are telling compiler to scan. So first we were telling compiler to enter these things, that is gender, year of service and qualification. So we were telling compiler telling user to enter those service. After that data is entered, we are scanning it with scanf function, that is %c is for character, that is g, that is ampersand g is character. Now %d is ampersand yos, that is year of service, which is in integer, that's why %d is written. Now %d is equal to and qual, that is qualification. Now up to here we have taken data. Now here after this we will be comparing this data with our logical operators, and thus print the output. Now the if section starts here. Now the if section is starting, that is if j, that is gender, is equal to m, that is male, and year of service is more than 10, and qual is equal to 1, salary 15,000. Now else if g is equal to m. So this is first comparison, that is for if statement. So salary is 15,000. Now else if g is equal to m, and year of service is more than 10, then qual is equal to 0, or g is equal to m, and yos is less than 10, and qual is equal to 1. Now salary is 10,000. So printf salary of employee is %d, sal. So that is basically using logical operators we can basically print all those sections, or all those charts comparison. So using logical operator is always easy as compared to if nested if else. So we can use both nested if else also and logical operators also. So using logical operator is useful. We can notice from this example that the not operator. So not operator is used when we don't want any condition to be satisfied. So far we have used only the logical operators and, or. The third logical operator is the not operator, written as like this. So it looks like an exclamatory mark. So far we have used only the logical operator. So we have used only and an or operator, but third logical operator is not operator. Now this operator reverses the result of expression. It operates on, for example, it operates so this operation reverses the results of expression it operates on. That means uh, it is reversing the result on expression which is operating. That means on which it is being applied. For example, if expression evaluates to a non-zero value, then applying not operator to it results into. So for example, if expression evaluates to non-zero value, then applying not operator to it results into cancellation. That means so applying not operator results into zero. That means if it is non-zero, then it will result into zero. Vice versa, if the expression evaluates to 0, then applying not operator to it makes it 1. So if expression evaluates to 0, then applying 1 operator to it makes it 1. So it is vice versa of that 1 and 0. Now a non-zero value, so the final result after applying not operator, 0 or 1 is considered to be false or true. So the final result is considered to be 0 or 1 respectively. Here is an example of not operator applied to relational expression. So this is an example. Now not y is less than 10. So this is an expression. This means not y less than 10. In other words, if y is less than 10, the expression will be false. So it means that not y less than 10. That means if y is less than 10, the expression will be false. Since y is less than 10 is true, we can express same condition as y is more than or is equal to 2. Y is more than or equal to 2. That means it reverses the result. The not operator is often used to reverse the logical value of a single variable as in the expression. So not operator is used for reversing the logical value of a single variable in expression. If not flag, this is another way of saying if flag is equal to 0. So does not operator sound confusing? Avoid it if you want. That means you can neglect it if it is sounding confusing to you. So we have list of different kind of operators. So on left hand side we have operators and on the right hand side we have type. So first is logical not operation. Then second is arithmetic and modulus operator. So arithmetic that means multiplication, it is division and modulus operator. Now plus minus, which are arithmetic operator. Now less than, greater than, less greater than, equal to, less than, equal to, these are relational operator. Now equal to or not equal to, these are also relational operator. Now and, so and is logical and operation. Or it is logical or operation. Now is equal to is assignment operator. Now a word of caution. So in this section we will first see a faulty program, that means program with a fault or which need to be repaired. and then we will understand what was wrong with it, and in next section we will write correct program. So first we will see faulty program. So this is a faulty program. First line is main, that is, this is a compulsory function which is used in every program. Now int I, so I is an integer. Now printf, enter value of I. So printf, that means enter value of I is, we are telling user to enter value of I. Now scanf, %d ampersand I. So because percent d is used because I is an integer. Now if I is equal to 5, that means if I is 5, that means we are here starting comparison. Printf, you entered 5. So if I is equal to 5, then printf, you entered 5. Else printf, you entered something other than 5. That means if I is equal to 5, you entered 5, else printf, you entered something other than 5. And here the program is ended because we are closing bracket. Now we will discuss about what is wrong with this program. Here we have used the assignment operator is equal to instead of relational operator is equal to is equal to. That means we have used only one sign of is equal to, so which was wrong with program. As a result, the condition gets reduced to if phi, irrespective of what you supply value of I. As a result, the condition is not getting satisfied. Remember, in C, truth is always non-zero, whereas falsity is always 0. That means truth is 1 and falsity is 0. Therefore, if phi always evaluates to true, and hence the result. So if we write if in bracket phi, so it will always evaluate to true, and hence the result. Now we will discuss about correct program. Now this is a correct program. So in this main is used. So main, after that bracket open, int I, that is integer is I is an integer. Now printf, enter value of I, that is we are telling user to enter value of I. Now scanf %d comma ampersand I, that is scanf the because a percent is used because I is an integer. Now if I is equal to 5, that means if I is equal to 5, printf entered, you entered 5. That means this is a correct program. And here is equal to is used 2 times. So this section was about word of caution, that means where you can go wrong. So this is very important that you have to write we have to write 2 times equal to sign for a comparison. The conditional operators, that is question mark and dot, are sometimes called ternary operators since they take 3 arguments. In fact, they form a kind of foreshortened if then else. That means conditional operators are used when we take 3 arguments. So their general form is expression, then a double dot, then question mark, expression 2, then dot, and then expression 3. So it is its general form of those conditional operators. So conditional operators are basically it represents conditions. So if one expression is true, then perform another expression, etc. So that kind of mechanism it has. What this expression says is, if expression 1 is true, that is if its value is non-zero, that means if expression 1 is true, then the value returned will be expression 2, otherwise value returned will be expression 3. So it is basically comparing from one expression to another expression. int x comma y. So x and y are integers. Then scanf %d comma ampersand x. Y is equal to x greater than 5 question mark 3 uh, 3 2 dots and 4. So this statement will store 3 in y if x is greater than 5. So it will store 3 in y if x is greater than 5. Otherwise it will store 4 in y. So if x is less than 5, it will store 4 in y, or it will store or if x is greater than 5, it will store 3 in y. Now we will see the equivalent if statement. So if x is greater than 5, y is 3, else y is 4. That means, so this is an equivalent if else statement for a conditional operator. Now char a int y scanf %c ampersand a. So y is equal to a, which is greater than or equal to 65, and a is less than or equal to 90, then 1 or 0. So here 1 would be assigned to y if a is greater than or equal to 65 and a is less than 90. So if this expression is evaluates to true, then it will store 1 in y, or otherwise 0 will be stored. So if both expressions are not true, then it will store 0. If it is true, it will store 1. A. It is not necessary that the conditional operator should be used only in arithmetic statements. That means it should not only be used in arithmetic statements. Example, integer I, scanf %d comma ampersand I. So if I is equal to 1 question mark printf Amit, or double dot printf all and sundry. That means this is different statement, a different sentence, that is print Amit or printf another statement. So not only arithmetic operations but also printf command can be used, also be used using conditional operators. Example, char a is equal to z, printf %c comma a is greater than or equal to a question mark a double dot not. So it is not necessary that only the conditional only the arithmetic instructions are used. Other instructions such as printf can also be used while using conditional operation. So check out following conditional expression. So we will discuss about another example of a conditional expression. So a is greater than b, then question mark g is equal to a, then double dot g is equal to b, semicolon. This will give you an error, L value required. So when we are typing this expression, we will get an error, and that error is L value required. The error can be overcome by enclosing the statement in the part within the pair of parentheses. So we have to apply various pair of parentheses in various statements. So the error can be overcome by enclosing the statement in the part within the pair of parentheses. This is shown below. Now correct statement is shown below. A is greater than b, question mark g is equal to a double dot g is equal to b in bracket and then semicolon. So this is a correct statement. In absence of parentheses, the compiler believes that B is being assigned to result of expression to the left of second is equal to, hence it reports an error. So usage of parentheses is required. uh, the limitation of conditional operators is it that after question mark or double dot only the C statement can one C statement can occur. So this is one of the limitation. Therefore in serious C programming, conditional operators aren't as frequently used as if else statements. Chapter 3, loops. The program that we have used you so far either a sequential or decision control instruction. So that means until now we have used the programs that were either a sequential or a decision control instructions. These programs were of limited nature because when executed they always perform the same series of actions. So these programs were of limited type of category. That means they were limited because when they were executed they always perform the same series of action. That means they were sequential. Almost always if something is worth doing, it is worth doing more than once. That means we have to do some important task again and again repeatedly. So that means if something is worth doing, that means something is important, then it should be done more than once. That means it should be done in loop. You can probably think of several examples of this form real life, such as eating a good dinner. So we can find the real life examples also of this problem. That means we have to do work or a task repeatedly. For example, eating a good dinner, going for a movie. So we want to watch one movie again and again sometimes, or we want to have same dinner, or if we like some kind of food, for example, tea or a particular tea that tastes good, or something food that tastes good. So we want to do that thing, like eating or going for a movie, going for a walk again and again in life. So in life also we do several tasks repeatedly. Now programming is the same. We frequently need to perform an action over and over. So that means programming is also same. In programming also we frequently need to perform an action over and over. Loops. The versatility of a computer lies in its ability to perform a set of instructions repeatedly. So versatility means the difference between human and computer. So versatility of computer lies in its ability to perform a set of instructions repeatedly. That means without getting tired, it can perform a set of instructions repeatedly. This involves repeating some portion of the program either a specified number of times until a particular condition is being satisfied. That means it involves repeating some portion of the program, so again and again. That means we have to repeat certain portion of a program. There are three methods by way of which we can repeat a part of a program. So there are three methods by which we are repeating a certain part of a program again and again. So these methods are: A, method A using a for statement, method B using a while statement, and method C using a do while statement. So these are three methods by which we can perform various tasks in loop. The while loop. So while loop is one of the loops in programming by which we can do a certain task repeatedly. So it is often the case in programming that you want to do something a fixed number of times. So it is often that we want to do something, that means we want to do something calculation or something task repeatedly. The while loop is ideally suited for the such cases. Let us look at a simple example which uses while loop. So while loop is ideally suited for such cases means while loop is used for repeating instructions. So we will see an example now. So this is a flowchart for while loop. This is an example actually. So in first block there is a start. So here we are starting. Now the arrow is pointing towards count is equal to 1. So initially count is 1. Then it is pointing towards is count is less than is equal to 3. So if yes, then input PNR. So this is for simple interest, and if no, then stop. Now SI is equal to P star N star R. That means P into N into R divided by 100. Now print SI, that is print simple interest. Now count is equal to count plus 1. That is a next up to next count. So and then it goes against to start. So this is flowchart for one example. Now we can write program using while loop using that flowchart. So first is main. So main is basically used in every program, so it is compulsory. Now int p comma n comma count. So p and n and count are integers. Now float r comma si. So r and si are float. Now count is equal to 1 because count was initially 1. Now while loop count is less than or equal to 3. So while count is less than or equal to 3. Now printf enter values of p comma n and r. So we are telling user to enter values of p, n and r. Now scanf %d %d %f ampersand p ampersand n ampersand r. That means we are telling compiler to scan these values. Now after scanning p, n and r values, now we can apply our formula for simple interest, that is SI is equal to p star n star r divided by 100. So this is formula for simple interest. Now printf simple interest is equal to rupees %f because that value is in float. Now SI is in float, so simple interest is equal to rs rupees %f SI, that is simple interest. Now count is equal to count plus 1 because we want to go again to 0. Not 0, we want to increase that count by 1. So this is program. Now we will discuss about output of this program. So and here are a few sample runs. That means we have some sample runs. Enter values of p and so these are outputs. First we entered 1005 and 13.5 and we got simple interest of rupees 675. Now we again tried another output. We entered 2005 and 13.5. Now simple interest is rupees 1350. Now we entered values 3500, 5 and 3.5. Now simple interest is rupees 612.50. So this is basically about program using an example using while loop. So as we seen in the while loop, the program executes all statements after while in 3 times, that is n times. That means how many times that we want to calculate. So program executes all statements after while 3 times. The logic for calculating the simple interest is written within pair of braces immediately after while keyword. So the logic for calculating the simple interest is written within pair of braces. That means there is a logic for calculating simple interest, that is p into n into r. Now these statements form what is called body of while loop. So whatever we write inside that while loop, it is called as body of while loop. The parenthesis after the while contain a condition so long as this condition remains true. So the parenthesis after the while contain a condition so long as the condition remains true. All state, that means count up to 3, count up to 4, that means this condition, until this condition remains true, so this will count. Now uh, remains true, all statements within body of while loop keep getting executed repeatedly. So all statement within body of while loop keep getting executed repeatedly. To begin with, variable count is initiated to 1. To begin with, the initial count is initialized, so we have to begin somewhere. So the variable count is initialized to 1. That means we are starting from 1, so we can start from 0 also, but we can start from 1 also. So we have to initialize from somewhere. To begin with, the variable count is initialized to 1, and every time the simple interest logic is executed, the value of count is incremented by 1. That means every time simple interest logic is performed, the value of count is incremented by 1. The variable count is many times called either a loop counter or an index variable. So the variable count that is up to 3, up to 4, it can be called as either a loop counter or an index variable. So loop counter or index variable is the count uh, of how many times we want to calculate a certain task, or how many times we want to perform repeatedly certain tasks. So that is loop counter or index variable. Tips and traps. General form of while loop is as shown below. So general form of while loop is as follows. Initialize loop counter. So while test loop counter using a condition, that means do until a certain limit, that is while. Test loop counter using a condition, then do this and this and increment loop counter. So this is basically a format of using while loop. That is, in while loop we are first giving a condition up to which we want to calculate, then do this and this and increment loop counter. That means we are performing some task and then we are incrementing that counter. Note the following points about while loop. The statements within the while loop would keep on getting executed till the condition being tested remains true. When condition becomes false, the control passes to first statement that follows the body of while loop. That means, not that so these are important points. First is, statements within while loop would keep on getting executed, so they are repeated until the condition is being tested. That means up to 3, up to 4 times, up to 5 times, that is condition being tested remains true. When condition become false, that is it is that means it is counted up to 3 times, so the condition is becoming false. The control passes to first statement that follows the body of while loop. That means uh, it ends after that condition is being false. Now the condition being tested may use relational or logical operator as shown in the following example. So how these conditions are, these are as follows. That means first is while I is less than or equal to 10, while I is greater than or equal to 10, and so while I is less than or equal to 10 means up to 10 we have to calculate. So this is first condition. Then while I is less than or equal to 10, and j is less than equal to 15, so this is another condition. And see then this is after this is another condition. So these are logical conditions, can also be used in while loop. So it is performed up until these conditions are satisfied, that is these are true. Once they are false, then this counter stops. The statement within the loop may be single line or block or statement. In the first case, the parentheses are optional. So basically statement within the loop can be a single line or block of statements. Now these are examples. While I is less than or equal to 10, I is equal to I plus 1. It's same as while I is less than or equal to 10, in bracket I is equal to I plus 1. That means parentheses are optional. So we can write parentheses, and we can, it is not compulsory to write parentheses. As a rule, the while must test a condition that will eventually become false. So while must test a condition that will eventually become false, otherwise the loop would be executed forever indefinitely. That means the while loop must test a condition that will become false, or otherwise it will be executed forever. So main int I is equal to 1. That means I is an integer, so which is equal to 1. Now while I is less than or equal to 10, printf d n. That means this will indefinite loop since I remains or equal to 1 forever. So that means we can write one number repeatedly. So I is a number which is 1, so it will be written 10 times on next line. So n is written for next line, that is in printf command %d slash n comma I. So I will be written 10 times. So this is an indefinite loop since I remains equal to 1 forever. So that is why it is indefinite loop. The correct form of would be as under: main int I is equal to 1 while I is less than or equal to 10, printf %d slash n I is equal to I plus 1. So here I will be incremented. I is getting incremented here. Instead of incrementing a loop counter, we can even decrement it and still manage to get body of loop executed repeatedly in shown below. So in this example we were incremented, that is I plus 1. So I will be written from 1 to 10, and we can decrement also. So this is program for decrementing. Now int I is equal to 5 while I is greater than or equal to 1, printf in next line make the computer literate I is equal to I minus 1. So this is program for decrementing. Just like incrementing, this is program for decrementing values. It is not necessary that loop counter must only be an int, it can even be float. So loop counter can also be float. Main, now float a is equal to 10.0 while a is less than or equal to 10.5, printf n raindrops on roses, printf and whiskers on kitten, a is equal to a plus 0.1. So it can be float also, it is not necessarily an integer always. Even floating point loop counters can be decremented. Once again, the increment and decrement can be of any value, not necessarily 1. So increment or decrement is not necessarily by 1. So in this program, main int I is equal to 1 because I is an integer, while I is less than or equal to 32767, printf %d slash n I is equal to I plus 1. So that means increment and decrement. So here we can write I is equal to I plus 2 also. So it is not necessarily I plus 1. more operators. There are variety of operators which are frequently used with while. So within while loop there are various operators which are used. So main, so first line is main, so it is used in every program. Int I is equal to 1 because I is equal to 1 is an integer. Now while loop until I is less than or equal to 10. Printf %d n comma I plus plus. So this program will write number from 1 to 10. Note that the increment operator plus plus increments the value of I by 1 every time the statement I plus plus gets executed. Similarly, to reduce value of a variable by 1, a decrement operator minus minus is also available. So in this program, int I is equal to 1 because I is an integer, while up until I is less than or equal to 10, printf %dn comma I. Now I plus or equal to 1, then bracket close. Note that plus is equal to is a compound assignment operator. It increments the value by 1, value of I by 1. Similarly, j is equal to j plus 10 can also be written as j plus or equal to 10. Other compound, so similarly j is equal to j plus 10 can also be written as j plus or is equal to 10. Now other compound assignment operators are minus equal to, star equal to, 1 equal to, and modulus, that is percentage, is equal to. Now main int I is equal to 0 while I plus plus is less than 10, printf %d n I. In this statement, while I plus plus is less than 10, firstly the comparison of value of I with 10 is performed, and then incrementation of I happens after its usage. Here the plus plus operator is also called post incrementation operator. So here plus plus operator is called post incrementation operator. When control reaches printf, I has already been incremented, hence I must be initialized to 0. Main int I is equal to 0 while plus plus I is less than or equal to 10, printf %d n I. In this statement, while plus plus I is less than or equal to 10, firstly incrementation of I takes place, then the comparison of value of I with 10 is performed. Since incrementation of I happens before its usage, here the plus plus operator is called pre-incrementation operator. So here plus plus operator is called pre-incrementation operator. The for loop. Perhaps one, so we will discuss about for loop in this section. Perhaps one reason why few programmers use while is that they are too busy using for. So very few programmers use while loop because the for loop is more useful or attractive for programmers. So one reason why few programmers use while is that they are too busy using for loop. The for allows us to specify three things about a loop in a single line. So for loop is allowing us to specify three things about a loop in a single line. A is setting a loop counter to initial value first. Then B is testing the loop counter to determine whether its value has reached number of repetitions desired. So first it is setting a loop counter to initial value. So it sets loop counter to initial value. Then B is testing the loop counter to determine whether its value has reached the number of repetitions desired. That means up to 5 times, up to 6 times. Is is that reached. That means whether its value has reached the number of repetitions desired, that means up to 6, up to 7, etc. C. Increasing the value of loop counter each time the program segment within loop has been executed. So it increases the value of loop counter each time the program segment has been executed. The general form of for statement is as under. For initial counter, then test counter, increment counter. So this is general form. First is initialize counter. Then so that means from 0 or from where to start. Then test counter, that means up to what extent it should go. And then increment counter means plus plus, that means increase or decrease, etc. And then in parenthesis we write do this and this and this, that means we write statements. Let us write down the simple interest program using for. Compare this program with one which we wrote using while. So here we are writing a program and comparing this program with one we wrote using while. The flowchart is also given below for better understanding. So first is we start. So this is flowchart for a program in which we are using for loop. So this is program for simple interest for three sets of P, N and R. So first we are writing start, then count is equal to 1, then count is equal to count plus 1, then is count is less than or equal to 3. So that means, so count is 1, that means initially count is 1. Now count is equal to count plus 1. So that is repeated after this. So first is count is initially 1, and that means we are starting from 1. Now arrow is pointing toward is count is less than or equal to 3. So if count is less than or equal to 3, if it is no, then we are stopping program, and if it is yes, then we are taking input P and R. Then arrow is pointing towards simple interest formula, that is SI is equal to P star N star R divided by 100. Now we are printing simple interest SI, and then again we are going to count is equal to count plus 1. Now again we are checking is count is less than or equal to 3, and again we are calculating simple interest and printing simple interest. And if it is not less than or equal to 3, then we are stopping the program. Now calculation of simple interest for three sets P of P, N and R. So first is main, so it is used in every program. So int P comma N comma count, so these are integers, P, N and count are integers. Now float is R comma SI, that means R and SI are float. For then we apply for loop, count is equal to 1, count is less than or equal to 3, then count is equal to count plus 1. Now loop starts, printf enter value of P, N and R. So here we are taking values. Here we are asking user to enter values. Now scanf %d %d %f, that means we are scanning those values which we have entered. So %d %d and %f. %d is used because it is a integer value, and %f is used because it is a float value. Now ampersand P ampersand N ampersand R. Now simple interest is equal to P star N star R divided by 100. So this is formula for simple interest. Now printf simple interest is equal to rupees %f /n. /n is for next line, comma SI. So SI was simple interest. Now at the place of %f, simple interest, that is SI, will be written. So output will be simple interest is equal to SI. So it will be written up to count is count is less than or equal to 3. This program is for calculating simple interest using for loop. So here for is used for count is equal to 1, then count is less than or equal to 3, then count is equal to count plus 1. So for loop is used for that. If this program is compared with while, it can be seen that 3 steps: initialization, testing and incrementation required for the loop construct we have now been incorporated in the statement, in the for statement. So that means in for statement 3 steps are there. First is initialization, then testing and incrementation. So these are steps which are required while using for statement. Now let us examine how the for statement gets executed. So these are steps for statement to get executed. When the for statement is executed for first time, the value of count is set to initial value 1. So first value is set to initial value 1. So this is first step. Now the condition count is less than or equal to 3 is tested. Since count is 1, the condition is satisfied and body of loop is executed first time. So this is second step, that now the condition count is less than or equal to 3 is tested. So this is second condition. Now upon reaching the closing brace for control is sent back to the for statement where the value of count gets incremented by 1. That means first it is set at initial value. Now it tests that condition, that is count is less than or equal to 3, and then in third portion we increment this value by 1. Again the test is performed to check whether new value of count exceeds 3. That means a test is performed to check whether a new value of count is exceeding 3. Now if the value of count is still within the range 1 to 3, the statements within the braces of for are executed again. That means within the range from 1 to 3, in second condition it is comparing that is it up to 3. That's why it is said that if the value of count is still within the range 1 to 3, the statements within the braces of for are executed again. That means uh, it will range from 1 to 3. It will start from, after starting from 1, it will check that condition up to 3. Now the statements within braces of for are executed again. The body of for loop continues to get executed till count doesn't exceed the final value 3. That means till the count reaches up to final value, that is 3, the body of loop continues to get executed. Now when count reaches the value 4, the control exit from loop and transfer to the statements, if any, immediately after body of for. So after reaching that particular value, that statement is stopping. So this is a flowchart for program. First is start, now initialize, now test. If condition is false, then stop. If it is true, then body of loop and then increment. And after incrementation again test. So this is flowchart for the program. It is important to note that the initialization, testing and incrementation part of for loop can be replaced by any valid expression. So here we know that uh, initialization, testing and the incrementation. So this part can be replaced. That means now in first statement for I is equal to 10, then I and I minus minus. So here it is uh, So the first part is replaced. Now I is less than 4, then j is equal to 5, j is equal to 0. Printf percent d I. So here it is also replaced by another expression. Now for I is equal to 1, then I is less than or equal to 10, then printf percent d I plus plus. That means here commands also are being used. Now for scanf percent d and I is less than or equal to 10, I plus plus. Printf percent d I. So here that part is replaced. Now program A, main int I for I is equal to 1, I is less than or equal to 10, I is equal to I plus 1. Printf percent d slash n I. Note that the initialization, then testing and incrementation of loop counter is done in for statement itself. Instead of I is equal to I plus 1, the statements I plus plus or I plus is equal to 1 can also be used. So instead of I is equal to I plus 1, the statement I plus plus or I plus or equal to 1 can also be used. Since there is only one statement in body of for loop, the pair of braces have been dropped. As with the while, default scope of for is the immediately next statement after it. So as with the while, default scope of for is the immediately next statement after for. So program B, main int I for I is equal to 1, I is less than or equal to 10. Printf percent d slash n I is equal to I plus 1. Here the incrementation is done within the body of for loop and not in the for statement. So here the incrementation is done within body of for loop and not in the for statement. Now program C, main int I is equal to 1 for I is less than 10, then I is equal to I plus 1. Printf percent d slash ni. Here the initialization in done in the declaration statement itself, but still the semicolon before condition is necessary because uh, the initialization is done in the statement. That means is not done in statement, but it is done in int I is equal to 1. So it is not necessary in for statement to write such initialization. Now D, main int I is equal to 1 for I is less than or equal to 10, printf percent d n comma I is equal to I plus 1. Here neither the initialization nor the incrementation is done in for statement, but still two semicolons are necessary. So here the initialization is done in int I is equal to 1, so that is initialization. Now that incrementation is done in I is equal to I plus 1, so that is incrementation. So but in for statement, two semicolons are given before I is less than or equal to 10, so those are necessary. So it is not necessary to write everything in for statement, you can write it separately also, like it is written in example D, that is program D. This is program in which incrementation as well as compilation is done through same statement. So the program is the program E, main int I for I is equal to 0, I plus plus less than 10, printf percent d slash n comma I. So here in this statement I plus plus less than 10, the incrementation as well as compilation is done. Since the plus plus operator comes after I, firstly the comparison is done. So since plus plus operator is coming after I, so so firstly the comparison is done, followed by incrementation. Note that it is necessary to initialize I to 0. So initialization first is necessary. main int I for I is equal to 0 plus I less than or equal to 10, printf %d slash n comma I. So in this program, both comparison and incrementation is done through same statement, that is plus I is less than or equal to 10. So here the comparison element is adding, that is less than or equal to. So or equal to is comparison element, that is equality also, it is also added. Now nesting in loops. The way if statements can be nested, similarly whiles and fors can also be nested. So if and else are nested, we know that nested if else statements are there. Similarly, whiles and fors, they can also be nested. So this is program for demonstration of nested loops. Main int r comma c comma sum. So r, c and sum are integers. Now for loop, r is equal to 1, r is less than or equal to 3, r plus plus. So this is outer loop. Now inner loop, for c is equal to 1, c is less than or equal to 2 and c plus plus. This is inner loop. So for is also nested here. Now sum is equal to r plus c printf. So we are adding r plus c. Printf r percent c, r percent d, c is equal to percent d, sum is equal to percent d slash n, r comma c comma sum. So this is program for nested if else statement, like for statement. That means for statements are nested here in nested loop. Multiple initializations in the for loop. The initialization expression of the for loop can contain more than one statement separated by comma. So multiple initializations in for loop. So for I is equal to 1, j is equal to 2, j is less than or equal to 10, j plus plus. So this is expression for loop. It can contain more than one statement. Multiple statements can also be used in the incrementation expression for loop. So multiple statements can also be used in incrementation expression. However, only one expression is allowed in test expression. This expression may contain several conditions linked together using logical operators. So here along with I, j is also there. That means when I is equal to 1, j is equal to 2, j is less than or equal to 10, j plus plus. So here two variables are used now. That is I also and j is also used. So we can add multiple statements in this for loop also. The odd loop that we have used so far executed the statements within them if a finite number of times. That means finite means the limited number.